next gen communication system. Before we get into the resource person, I just want to give a brief introduction about our resource person. He has completed his Bachelor of Computer Application from Alagappa University, Karaikudi, in the year between 2005 and 8. And he has done his master's, there is MBA in International Business from Annamalai University between 2011 and 14. After his education, he worked in several projects. He was a software engineer at Samsung Electronics, associate with Laser and Turbo Infotech, Mysore, and he was a senior engineer at Smart Play Technologies, Android RIL, and telephony developer at Samsung India Software Operations Bangalore. He was a part of R&D team at Qualcomm Technologies, California, USA. Senior technical leader at Ascent San Francisco, and also Android platform developer at Intel Corporation. He was also worked at Meta as an Android framework engineer. He started his entrepreneurial journey parallelly because of his passion towards entrepreneurship. He is also a CEO of Skywalk Robotics Academy, which is started in the year 2018, which is mainly focused on training, services, and maintenance related to drones. And in 2027, he has started another startup called Astro Aerospace to concentrate more on artificial intelligence and hardware design, software development, and manufacturing to meet the unique needs of the drone industry. So, with this few words, I hand over the session to our resource person. And thank you, sir. Thank you for your joining
Thank
in
you.
your busy schedule. Thank you so much, sir. You can
Thank
start, sir. Yes.
Thank you. And I heartily welcome one and all. And very good afternoon. I hope you all had a good lunch. And here time is 12:30 a.m. So it's quite a midnight. I just refreshed and came back. First of all, I like to thank Hindustan College and our coordinator Saravanan Kumar and whoever the senior persons there, and AICTE and ATL. So I feel like when I heard this, I felt so good because I'm here, but my all interest and my passion, everything, I always focus on India and Indian drone development systems. So first, I like to start with thanking for the opportunity. Then, yes, I like to know more about the participants also. If anybody want to intro, you guys can go ahead. So, yeah, the moment I heard from Sharon, like I need to talk more about the drone technology and also the future next generation. So I come up with some agenda for today. So I'll be talking, but I like to have kind of an interaction session, like instead of because it's online, right? Because if it is in person, at least I can see your faces. I see a lot of people are even turned off the camera, turned on the microphone, but still, if anybody good feel good, or you guys can turn on the camera, please turn on the camera. It'll be good because I feel good to see your face to face and talk because it's already a midnight here and I am the lonely person talking. So feel free to turn on. It's good, like, yeah, we are done with COVID, like no more COVID, like we can speak each other. So yeah, I really want to be the interactive, like I'm not the person who don't want to keep talking. See, I'm here. So first of all, I like to take a few minutes to talk about me. Of course, Saranand covered all my 20 years of journey in 2 minutes. Thank you, Saranand, for that. Looks like he did a lot of research on my profile too. I could recall, oh yes, I was working in Intel, right? Okay. So suddenly few things are remembering me. Thank you, Saranand. So yes, so few minutes I'll talk about me and my profession. Of course, little more whatever Saranand missed. And after that, I'll jump on to the core topic of AI. What is the role in AI with respect to UA technologies and also the drone, and also where all we use AI and why we use AI. So that will be kind of 15 minutes. And another 15 minutes, I'll talk more about the next gen communication, which is the 5G and IoT we call. Instead of IoT, Internet of Things, here we name it as IoT, which is Internet of Drones. Maybe some people would have already known. So maybe I'll be a little bit repetitive, but yeah, I like to talk about that and about edge computing and cloud computing. I'm not sure whether it's part of your academic but recently that is really getting evolved with the computing. So I like to talk about that. Finally, I'll be. Is it some message, Saranam?
No, sir. I'll no, sir. It's just a transcript message, sir. You can.
Okay, fine. Okay, fine. And finally, I'll be giving a brief end keynotes, like what's a summary and what are the opportunities we can look forward, and how will be the another 10 years or 20 years from now on with respect to drones and then we can have a Q&A. With that, yeah. First of all, I like to hear some hello, hi, or something, whoever online, please. So, if someone like to introduce at least top five people, someone can introduce around. I want to know more about the audience also.
Yes, sir. For this, you can just give a small introduction. Yes, ma'am. You can go ahead.
Good afternoon, sir.
Good afternoon.
Sir, myself Dr. J. Booma from PSNA College of Engineering and Technology.
Mhm.
We are connected here for the past 5 days.
Oh,
And nice to talk to you. And we are eagerly awaiting for your lecture, sir.
of course. Yeah,
Thank you, sir.
for sure. Thank you for stopping in. Yep. Anybody else? Anybody else? First of all, you guys are okay with my language, right? இல்ல தமிழ்ல பேசணும்னா தமிழ் okay தான். So you guys can follow with me.
Sir,
My language.
we have 30 to 40 participants joining from North India also, sir. From
Oh,
Gujarat and
that's good
Andhra.
to know. Oh, good to know. Good
All
to
over, we
know.
have audience from all over India. Yes, sir.
Oh, wonderful, wonderful. That's good. That's good. So, but my language you guys are following, right? Is it okay? Whatever I'm speaking, is
Yes,
it
sir.
clear?
It's convenient, sir. You can proceed in the same way. Thank you, sir.
Perfect. Thank you so much. Okay. Okay, let me begin. So yeah, it's me, of course. Wherever Saran mentioned, everywhere I taken a picture already. So to show you guys. So so of course you taken from the LinkedIn. So this is there. So myself, Ganesh Ramamurthy. So I'm almost 18 now, I think. It's like 16 to 18 years of experience in the software industry mainly. As soon as I finished my graduation, I got placed in L&T Infotech in the campus interview. I began as a mobile programmer. Uh, After mobile programming, since my interest more went on towards the mobile, because in 2007 and 8 and 10, like now how they're drawn and a lot of new thing, during that time mobile were booming up. So I just got interest and I got opportunity to go to South Korea. I was in South Korea for 2 years and I was doing a lot of R&D, and I got the opportunity to work in Samsung first phone, which you all know, the Galaxy phone, right? So I was part of the Galaxy phone, like how you guys can use the cameras, contact settings. These are the things like I worked on the UI and also. So with that, from there only, actually my the core technology career has begun in South Korea. So I was part of the core Samsung R&D team, and then once I come back, I got more interest towards that. Then I was working in Samsung India. Then I got opportunity to work, came to United States in 2015. My first company I worked with, Qualcomm Research Center. So again, I was R&D engineer there. I was working for there one of the SDK, we call it as a software development kit. So they Qualcomm is primarily known as a SoC. We call it as a chipset company. So they have a number of chipsets. So I was the one who, I mean, I don't want to say I was the one, because there are 10,000s or I mean hundreds of people, 100K people are working. So I was a small R&D guy, so who was doing some research on the software. So after that, I got opportunity to come to Intel. So in Intel, I was working on the small devices. So in 2016 and 17, we had a glasses, like interactive glasses. So like especially the athletics or person, the blind person or somebody, they can wear a glass which they can interact, even the navigation, everything through the glasses. So it was a very cool technology. I was part of the R&D team. Then I came to Meta also. It's like you can see the technology evaluation. Like I started with Android, then Android small application I was doing. Then it comes with the more like a voice assistant interactive thing. Then in Meta also I was doing kind of a Meta platform development. Then in 2021 I got opportunity to move to Lucid Motors. So Lucid Motors is a pure electrical vehicle and fully autonomous vehicle. So I was part of the infotainment technology leader, and I take care of developing the whole infotainment Android the ecosystem. Basically, you can hear a music, you can play some games, sort of things, but mostly on the platform side. So this is about me. Of course, yeah, few things I would have confused, but yeah. So this is on my core professional stuff and what I do day to day in US. Apart from that, of course, I was part of, as you mentioned, as an entrepreneur journey. Yeah, yeah, since 2015, the moment I came here, I started exploring like, okay, we are here, like what else we can do in India. Okay, so then that's where like me, of course, Suresh Narayanan and few more people, we joined together. We started our cool idea R&D in 2017 itself. So we did almost 1 year market study, everything. Then we come up with some demand in India where people can be utilized for a future. So that's where we started Skywalk Robotics, which primarily a drone pilot organization, and we were giving the advanced training, like not just learning. We also take care of a crash course from the aerial cinematography and also in depth of the drone. So we have been part of the media like India Glitz Behind Hood, and also we came in some news, and we in fact we did some drone the gaming activity at Hindustan. Of course, Saranan was part of it. That was one good. I mean, kids. I mean, like students were really getting interested towards that. Of course, we did once and we couldn't do, but we'll do it for again for sure. So that's part of Skywalk Robotics, and under that again we formed another group called Android, where we recently got a DGC approved also. So that means now Skywalk is fully matured to become a RP2 also. So that was one good achievement I can say. Like we started as a simple drone training academy, and today we are here. And for especially for your car people, like Skywalk will be the end-to-end solution where you can come, you learn a lot about the drone. And why Astro Aerospace? Yes, so we were doing more focused on the drone pilot training and those things. Then the bigger thing, like what actually future market needed, which we were missing. So of course, because also like a lot of people, especially the college students and everybody interested in training, doing manual things. Okay, but now all world is moving towards AI and transforming into artificial intelligence and moving towards autonomous system. Okay, so keeping that in mind, then we thought like, oh, wait a minute, then because whole world, because since I'm in US here, because I could see a lot of technology change and advancement in day-to-day my life. I can see the real need of the artificial intelligence and also the demand. So keeping that in mind, then we thought like, oh yes, so then something we are missing. The drone right now, nobody is interested or nobody is focusing, meaning on the technology side, everybody want already pre-built drone. They want some DJI drone or they want to build their own FPV drones, but nobody want to involve on the technology, what drone really needed. So that's where we formed this, and we are right now still we are in R&D. We are not yet become a product or service, but still we are doing a lot of R&D, starting from the drone and also the firmware, what drone really needed, and also the ground station, what drone can be controlled, and also we are developing a one platform. So our platform will look something like this. So our intention was, okay, if tomorrow people, as if from the Skywalk, we are ready to give the pilot training. We can teach people what is hardware, what is inside drone, how to recover a drone. Drones all are okay. Okay, tomorrow we want to develop our own drone. What else we are missing? Then the key part, what we are missing is a software. Okay, so then we thought, okay, then can we build a one whole platform? So the platform will contain the brain, like which is the whole framework, which will take care of the whole drone firmware. Like basically, you guys know, like if you guys know about the PixOC, so you just flash the PixOC, then it will do the drone flying and all the UAV systems. So that also we plan to. We are right now developing in-house. Then comes the ground station management, where drone needs to be controlled without the pilot. So that also we are right now developing, and also comes with the enterprise application, because right now what people you guys are using on the mobile phone, tomorrow everybody wants similar kind of ecosystem for drones also. So right now none of the companies are really focused, but there is a huge potential for that, and also like huge technology demand for that. So tomorrow for any drone you go, that you need applications also. So that's where, I mean, I will not take much time, but I can come back here. But yeah, this is our Astro platform architecture diagram. Here you can see we start from hardware and we deal with the enterprise application, which is end to end. So yep, so part of this our team R&D, we are doing a lot of development, a lot of job opportunities, a lot of things are happening, but yeah, I can cover at the end. Yes, so let's begin to the topic. Till now, any questions? Anybody has anything? At least one person has something. Any questions? Any doubts? What I'm doing? Why I'm doing? I see 67 people. That's a huge people. No, can you be a little louder? I can't hear you.
So you are talking about the enterprise level application, right? Is it catering to different kinds of application segments? So you give a like enterprise level structure architecture?
No, no. See, our architecture is a one-stop architecture. This is a Astro architecture. Okay. So using our platform, you can build the enterprise application. Tomorrow, you see, defense is asking for different application. Agriculture may need different kind of applications, right? So we are developing our platform. Basically, we are developing a software stack. That stack will be compatible for any industrial drone application development. Get it?
Okay, sir. Okay. SDK kind of stuff.
Yep, correct. Yeah.
Yeah, thank you.
Awesome. So thank you for the question. And yeah, Boma, please.
Uh, yes, sir. Sir, might have a very basic question, but during your lecture, if you can give an the simple brief explanations regarding my questions, if possible. I'm basically doubting about the things. How was the data from an UAV processed and analyzed for our decision making? Or is there any, what should be the importance of the communication modules in UAV swarming technologies also?
Sure.
Okay, sir.
Mostly, I think it will be covered in my slide. If not,
Sure,
we can
sir.
come back to this question back again. Okay, that's
Sure,
very
sir.
good.
Thank you.
I hopefully my slide covers that. If not, I can answer that at the end, Boma. Is it okay?
Yes, thank you, sir.
Thank you. Perfect. Okay,
Sir, I have one more question.
go ahead.
Yeah, just now you are speaking about some platform, right? Software platform which can be used for developing different enterprise level applications. In the
Mm-hmm.
same way, can I think of developing an ASIC kind of thing which can cater to multiple service segments, multiple application segments?
Correct, but that depends on the what kind of platform you use, because say right now what we are developing with on top of the open source, right? Because open source gives us a lot of inbuilt components. If you want to develop from your scratch, then you need to consider all the communication blocks. So if you are able to build that, then you can for sure do that. Yeah, go ahead. Yeah,
Yeah, thank you, sir. Done.
thank you. Perfect. Okay, wonderful. Yeah, so okay, so let's get into the UAV. Of course, I think, yeah, you all are already expert in UAV, or you know theoretically how it works. Of course, there's just a definition. I always start with it, like, yeah, so unmanned aerial vehicle, because same UAV I'll be using here and there. So you guys should know what is UAV. So that's why I just put a one slide. So UAV is like an unmanned aerial vehicle, which will be used, I mean, like referred to the aircraft, which will be flied without a pilot on board. Okay, so and of course the drone is used for multiple use cases. It can be used for agriculture, or it can be used for monitoring, surveillance, recent time for wedding photographies, lot more thing. And it has different components in it. What all it'll have primarily the what is that, like a motors, and also the camera, sensors, communication devices, and these are, I mean, like lot more propellers. We have a extra, we have a hexagon. So there are different models of drone, but based on the industrial need, the drone sizes will vary. It starts from micro, small categories of drones will be used in a different industrial needs. So let's get into the AI. So I have a small video. You guys can just watch out. Please confirm. Let me know if you don't hear the volume, please.
Advancements in AI drones
You guys can hear. Everybody can hear, right? Awesome.
Yes, sir. Fine, sir.
Yeah.
technology, shaping the future of aerial surveillance. Prepare to be awestruck as the enthralling dance of autonomous drones and the enchanted domain of artificial intelligence lift flight, ushering in a marvelous revolution. As technology advances to unprecedented heights, The wings powered by artificial intelligence drones spread with limitless possibilities. These majestic wonders have a rare combination of power and flexibility, breaking down barriers in agriculture, construction, and monitoring, and even rising as beacons of hope in times of disaster. As AI merges with the drone's heavenly essence, their capability surges, driving them to the forefront of innovation. These heavenly messengers have surpassed the borders of the unknown with their newfound synergy, making them not only fearsome but also easily available to anyone who dares to dream. So I think now you can guess what the area we are going to explore today is. Advancements in AI drones technology, shaping the future of aerial surveillance. Let's get started.
Yeah. So, yep. So this is what today I'm going to talk more and more. Maybe a few will be uh, outside drone also, but yeah, mostly the AI and also the other communication things. Let me see. It got stuck. Okay, let's start from here. Yes. So yeah, introduction to AI. So I know you guys everywhere right now we are hearing AI, artificial intelligence, right? So what it exactly does, right? So it's basically does or it's basically a mission. So mission is programmed to do some job automatically without any interruption. Basically, add on intelligence. So equivalent to the human. Basically, if you can see here, like see number of cars are coming, so you want to count within few seconds, within less than micro millisecond you want to calculate how many car, how many bus are there, how difficult it is. Suppose as a human, if you ask me, I'll take at least maybe a 5 seconds to count number of cars in the street, right? But our AI, artificial intelligence, it can sense it less than 0.0.0.1 millisecond. So that is the power of intelligence, right? So that's where we are, the what human can think, how that can be improvised. So that's where the artificial intelligence is coming. I mean, intelligence is taken from the human because we are built with the brains, right? This is purely artificial thing. That means like the human, we are building the mission, right? So this powered with what? So basically a bunch of algorithms are written based on the requirements or the need. So if you see the internet there, they are basically counting number of people, or and in depth they want to count how many male, how many female, or how many wearing what kind of wears. So if those all want to be calculated or you want to accumulated, then artificial intelligence comes. So artificial intelligence algorithms can be trained to know whether it's a human, is a male or female, what kind of wear, whether he has any specs or he has any weapon. So those kind of processing the data which we inside the machine, which we call it as a artificial intelligence. So with this on the drone, so on the drone, why we need artificial intelligence? So I initially, when I started, like, so drone is normally used for flying, and of course it has a camera, so it can take bunch of pictures. Okay, I thought only that, because when I started in 2017, people were using drones only for the photography mainly. Even till today, some people use only for photography, right? So other than that, but drone can be done for multiple other purpose, right? It, once you add the technology in it, it can do enormous purpose. It solves a lot of problems in day-to-day life. So when we integrate AI in our drone, it can just fly itself. So you don't need any human interruption or no more pilot needed. So that itself a big thing, right? So till today, we are just one person is controlling a drone. From tomorrow, if once the AI is come, once we make our drone autonomous, it's it can just fly itself. You can just give the coordinate. You say like just go from A to B, then it can just go do the job and it can come back. So that's a big lifesaver, right? So that's where the AI comes in picture. And also you see the advancement, it can be used in multiple industries. You can see here. So starting from defense, so of course the defense is our border police, right? So defense right now investing a lot for a AI with the drone combination. They really want to detect the whatever the threat or whatever the emergency, whatever the disasters, before it hit us, they want to protect us. So lot of intelligence has been added to the drone to protect to utilize in our defense. And of course agriculture, there are a lot of use cases which I'm going to list down. So future agriculture, it's going to be a lot of transformation will be there with help of drone on the AI. And of course the telecommunication, it is like a widely used one of the one, like you can see the cellular towers will be advanced, and also to monitor the cellular towers, what is the health of the cellular tower, to increase the range, those all drone can be used. And also the oil and gas field, of course the leakages, those are the few use cases where drones are getting again used. And the energy and utility, like of course like there are many towers which get defected, and power inspection. And recently we heard about the bird diverter installation. So in the energy sector also a lot of drone usage is there. And also the transportation, of course, like recently, especially the last mail delivery, we call it. So even in US, like recently we started seeing a drone is able to deliver a good. So even from the McD, the people are able to ship a burger to one store to the consumer. So a lot more things are coming. So transportation, of course, is the big change we can say. And of course public safety, the drones are widely used in case of any threat, or in case of big gathering, drones are widely used to save the people. Somebody interrupted? Any questions?
I think no, sir. Yes. No, no.
Yeah, and also the mining and the metals. So of course this is like uh, as per the history, as per the record shows, like a lot of lives has been given for mining purpose. But going forward, once the drone is there, a lot of lives can be saved, and also we can fine tune the data and we can improvise our whole economy. So these are the wider sectors where our drones are going to be used. Yes, yeah. So when I say AI, right, and we have a drone, okay. So this architecture is from Astrova, but still I really like to share with you guys and understand right, how it is going to be processed, okay, right. So when you say the drone, so drone has a camera, and it has a GPS model in it, right, and also it has own processor. So with this all, it can just fly, but it can't do any AI, right? On top of this, we have two options to do now. Add a AI. One is get the camera data, push it onto the cloud, and do all our AI operation and send it back to drone. This is option one. Option two, we call it as a onboard computer or companion computer. What is that? It is just another computer, which is a Raspberry Pi, which will be connected to the internet dongle, and then we will feed our all the algorithms, all our process, all our threads onto the component computer. So component computer will take a decision and immediately will give back the decision to the drone what to do. Let me go in depth of it little more. Okay, so let's take option one. Okay, so my drone don't have the component computer, it has a HereLink. HereLink is a transmitter which will transmit a data from the drone to the ground station. Okay. So in my ground station, I'm keep getting the live feed. Okay. So now let's take a use case. There is what to say. Okay. So there is one big gathering, and there is one person carrying a gun, or one person you want to follow, you want to track it, or some person is missing, you want to find in a biggest crowd. Okay, it's a very biggest task, right? Like suppose how can, so currently only way is police has to go there with the vehicle, or they have to put some siren, then they have to find a person, right? But they don't want to disturb, there is some, maybe some temple, some events are happening, they don't want to disturb the crowd, right? So let's take an example. Okay, so this data we want to detect or process it via the drone. So what drone can do? So drone can capture a feed. It can keep giving us a frame by frame data to HereLink. Okay. So what we will do is we will send that camera feed to the AWS. AWS is the cloud. Okay. Which has a advanced processing unit in it. Okay. So the moment we give the every frame, we build the algorithm in our SageMaker. Okay. So that SageMaker can detect whether that particular person, missing person, is available in the crowd, and then immediately that particular notification can be sent to the front end. Little more detail, I'll go little more detail. So how this AWS works? Okay, so this whole AI works in three format. Like, one is, first you should know what's your requirement, then you need to collect the data and you need to train a data. Okay, suppose you are here, I'm talking about the crowd monitoring solution. Crowd means then it's a human, right? So you need to train your AI model with the human, because that's how the art, that's how you build the robot, right? So robot how knows whether this is the pen or not? So to robot you should show a different pens and tell him, tomorrow when you say something like this is a pen, right? Tomorrow you see something like this is a mobile phone. So we have to train the model first. So you need to collect the data. So in Astrova we have a bunch of data engineers which worked day and night to gather a data. We call them as a data engineer. So they data engineer gather the data, then they will train a data. Okay, because collecting a data will have mixed, because one guy will having a white shirt, one guy will have a blue shirt, one guy will have a hoodie, one guy will have hair, one guy will not have hair, one guy will have hat. There are a lot of combinations, right? So you cannot just compare, say one person, you just mark my face and say, oh, he's a human, he's a man, and he is his name is Ganesh. You can't map like that, because there are plenty of people around across the world, right? We have different variants. So the beginning of AI is, first you have to collect the data, then you need to train the data. So once data has been trained, then you need to supply the data. So that's where the SageMaker comes. You see, whatever the S3 bucket, you can see on the back end the diagram, the S3 bucket, the Lambda, these all are the data collections. Once the data has been collected, so we now trained and kept it for the input. Now camera from the drone, the recording has been taken, it come to the here link, it is right now with the ground station, the frame has been sent to the SageMaker. Now the SageMaker has our algorithm. What is our algorithm? It can fine tune, or it can read in depth about the image frame, and it can sense based on the model whether he is the person, he is a male or female, or whether he is animal or whatever. So once SageMaker detect it, or it can add the bounded boxes, it will throw the data to the DynamoDB. So DynamoDB is a result. Okay, and in that result again one more filter will happen, because I don't want all the data, I want only the threat or only the affected data. So that data will be given back to the Lambda 2. From there it will be sent to the user interface. Any questions here? I'm just trying to understand. I know I'm going a little more deeper. Can anyone, at least one person in the audience, um, at least say you guys are understanding what I'm talking?
Sir, what is the purpose of DynamoDB and Lambda?
Yes. Good question. See, the SageMaker, right? Because the frame, I'm playing a video, right? Basically, it's a live data, right? So the frames, it has to be processed in a 0.0.1 micromillisecond. Okay. So that time, all the data SageMaker will detect immediately. It will push to the DB. Then I have another filter there. Okay, because I don't want to keep sending a junk data to the UI. So there will be a additional one more processing is involved. Basically, you can say the uh, algorithm is basically the core algorithm is taken care by the SageMaker, but the filtering part. Okay, we always have a something filtering or database, right? Because if tomorrow you want to revisit, okay, tomorrow, okay, now you find the threat, but you want to go in depth of it. Suppose out of 10 minutes, in 5th minute video there is a problem. I mean, you found one person is carrying a gun, example. Okay, so you want to go in depth of that 5 seconds, so you need the backup data, right? So that data will be available in the DynamoDB. So anytime you want to recap, you can always go back to Dynamo, because SageMaker is just a data communication process there. It just processes the data. You don't have any persist data here. So across AWS, we need the one persistent. You know what is persistent, right? You know what is persistent?
Yes, sir. Yes.
Yeah, persistent is like a data saving, right? So that's where the DynamoDB comes to picture.
Sir, where will be the model here?
So see, model is trained separately, okay, and given input as a kinesis. So kinesis is the input it takes. So basically all the models are trained and kept it in a S3 bucket.
Okay, sir. Okay.
Yeah. Thank you. Thank you for the question. So this is the one way of processing the AI from the drone. Okay. And as I said, second option, suppose tomorrow you are developing a drone for the defense. Okay. So defense, your drone will be flying across the border. There is no internet. That means you cannot connect to the AWS at all. So that means our option one cannot be used. How can we do that? So now that's where we provided another solution, which is called onboard computer we call, or onboard intelligence. Okay. So basically we have a companion computer which will be connected to the dongle, but it may not have a internet, but it will have a capability to process the data. Okay. Only in case you want to push the data to the ground station, you need the 5G or 4G communication. Else, your companion computer will have whatever here AWS was doing, same thing can be done in the companion computer, but no AWS, but processing can be done. And the decision, imagine they are also looking in the border, they are doing a surveillance. In case of anybody cross the border, they want to capture a video and send it to the ground station, or immediately they want to go near the person. Okay. So in that case, no internet will be involved. Component computer knows already because everything is trained and loaded. Okay. When the drone is flying, the immediately component computer will have your algorithm. It will detect a person. It will say like, oh, there is a person walking around the border. I have to go closer and record more data. So this is the immediate threat which is taken care by the drone on computer without internet communication. Okay. So onboard processing is the one, like where here whatever the SageMaker was doing, that all the algorithm will be loaded onto the component computer. So this is the whole architecture. I hope maybe I can come back to Boma. Is that
Sir, one question. This
okay?
here we are having lambda 1, lambda 2, lambda 3, lambda
Mhm.
4. What all that for?
No, in the AWS side or in the component computer side?
In the AWS side, sir. Sorry, like earlier I missed. I
Right,
asked for
right, right,
both.
right.
Yeah.
Okay. No, exactly. See, this lambda 1, lambda 2, you can say take it as a variables. See, if you initialize a program, right? So we always have a, like suppose I told you, right? There are every 100 millisecond, you will be getting a thousands of images from the as a video, because the drone is flying in the fast, right? So to process that, I need to give a time to SageMaker to think, to take a decision. I cannot, it won't be in a micro millisecond, right? So that's where you will have some processing. So that's where lambda, you can have it as a variable A, variable B. So before processing, you are putting it in a variable A, then you process it, put it into variable B, send it to DynamoDB, then you come, then the output will be in a S3 bucket. Even in the S3 bucket, you want to put it in another variable and give it to the output. You can consider this is like this is the AWS term, that is their internal part we want to highlight, because it's not a direct handshake, because Kinesis cannot talk to SageMaker. You understood, right? I need an intermediator. That is called lambda. So again, SageMaker cannot talk to S3 bucket. So that is mediator called lambda. Again, it's kind of a variable, or you can say the API link. Okay.
Okay, sir.
Again,
Thank you.
from
Thank
S3
you.
bucket, I cannot talk to the API gateway. Again, AWS provides a lambda function. Okay. To make it simple, lambda is a function call. Is it answering your question? It's a simple function
Yeah.
call.
Thank you, sir. Yeah. Yes, sir.
Yeah.
Yes, sir.
Yeah. So this answer a little bit of your question or still?
Yes, sir. Yes, sir. I can understand, but I'm making a replica of the same, sir. Whether you can tell me whether my understanding is right or wrong. So as far my question concerned, you told me that the data were collected. So the UAV gathered all the data, might have a chance within sensors like a camera or LIDAR or infrared, whatever it may be. So it depends on the applications we are using.
Correct.
And the collected data were transmitted, that is stored on a board or transmitted for in real time to the ground station as far as the application concerned.
Correct. That's
At the same time, before that, the pre-processing process were happened with a noise filtration or a data synchronizations, whatever it may be, it's comments in the next step. Then after a processing like an image stretching or an 3D modeling, or as far as our discussion concern, AI-based analysis of an identification patterns were processed.
correct. Those
Then,
all see. So basically,
yes,
we are relying only on the camera feed. Okay, any
camera.
sensor, any feed. You take lidar or any feed, right? Any sensor. Tomorrow, I'm adding a lidar sensor or any obstacle avoidance sensor, right? If I add it, so what? So obstacle avoidance case, the decision has to be taken in the onboard, right? We don't have much time, right? So in the onboard itself, we have a processor. We'll have an algorithm. So in case we have a distance algorithm, when the lidar reaches and it sends something, then immediately it has to move out or it has to return back to home, right? So such algorithms are written in the onboard computer. Okay, so these AWS, these processing is only in case of the camera images or camera feeds.
Well, sir.
Yeah, okay.
Okay, sir. Thank you, sir. Thanks for the explanation.
Thank you. Okay, let me move on. Yeah, oh, we have 15 minutes. Okay, so yeah, these all are more advancement about the importance of the AI and the future, because it is more efficient, which I already spoke. And also, like, you guys already know, like, what is AI? It's a combination of machine learning and computer vision. So machine learning, as I said, the model. So basically you are developing an algorithm which machine will learn itself. Okay, because today I'm learning something, but as a human, like, we may forget, or our learning will end sometime. But in case of machine, it's not like that. Machine can duplicate or it can increase its learning as fast as 100 times than human. Okay, so that's where this machine learning algorithm comes. In case of drone, especially you take the autonomous flight, machine learning is the key factor. So basically, when you are flying autonomously around the hill station, it should learn where is obstacles. It should learn if any trees are there, how much height is the tree, how much what is altitude I can fly. So those are the mission it can learn itself. And computer vision is on top of machine learning. Computer vision is a smaller, what do you say, the smaller algorithm or smaller intelligence what we write, that is called the computer vision programming. And also the final one, the edge computing, which I'll be talking more in detail. This is very important in case of drone, because here also two things are very important. Like, one is the decision making on board or decision making on cloud. So that's where the edge computer comes to picture. So I have another short video which will take you to the next topic.
AI-powered autonomous flight systems revolutionize drone technology, enabling them to navigate complex environments without human intervention. These systems use sensors, cameras, and advanced algorithms to monitor crop health, identify pests, optimize irrigation, and assist in construction, saving time and resources. AI is not only boosting productivity, but it is also improving the safety of drone operations. AI-powered collision avoidance systems are growing more advanced, allowing drones to recognize and avoid obstructions in their flight path. This is especially vital for drones flying in metropolitan areas or near key infrastructure, where mishaps are more likely. Furthermore, AI-powered drones may be utilized in search and rescue missions, assisting in the location of missing people or delivering critical supplies to disaster-stricken areas without endangering human lives. The use of AI in drone technology has also increased the accessibility of these gadgets to a larger variety of consumers. User-friendly interfaces and easy controls have eased drone operation, allowing even individuals with modest technical skills to reap the benefits of UAVs. This democratization of drone technology has created new opportunities for both enterprises and people, as they can now use the power of AI-powered drones to simplify operations and gain a competitive advantage.
Yeah, so here actually I played that because
AI-powered
to show you guys the AI powered drone, what are the best use cases you might have seen in the video. So it was used for the delivery purpose, it was used for emergency purpose, especially the agriculture, right? In agriculture also, like, very fine tuning, like not just flying or spraying, more than that. Okay, so that's where I was just showcasing that video. So let me move on. So yeah, so agriculture usage, you guys know, as I said, like, so right now agriculture farming, in fact, like, they are trying to do the crop health monitoring, soil condition, and also from the end to end, like before starting the farming, if I want to cultivate one particular crop, how much time it need, what all I need to do, what all I need to do for it, like what are the pest control I should use, what are the water level I should use, what are the fertilizer I should use. Everything can be pre-studied and provided to the farmers. So that level of data can be processed via taking the soil inspection through the drones. And of the infrastructure inspection right now, like that is also like other than surveillance. So right now, the bridges, power inspection, pipeline inspection, those are the very widely used ones. And also the the border control, security, and surveillance, and the search and rescue also. Like right now in the forest area, or in case of any missing things, so drones are widely used in case of search and rescue purpose. And as I mentioned in the scene in the video, like delivery service and disaster response, the drones are widely used. And the last mile delivery, which I said, like suppose the transportation wise, like if you see like a air or train or bus, which is done quicker, but when you see the last minute, dispatches are always delayed and expensive. To save that, drones are the good option, which is proposed, and a lot of countries have started using it. Yeah, and also the construction and surveying. So construction also, like the future construction is going to be drastically changed, not just the site mapping or the 3D modeling. It will be a lot more. The even the construction, it's going to be the monitored via the drone, and also the engineers safety purpose, and also the whoever the buyer, we can even provide the real-time data using it drones. And the military defense and also the wildlife, this is also widely used right now. The defense are very much interest, are showing the more investment towards the drone, especially the border protections, and also the wildlife, like especially the forest dangers or the saving the animals and also counting, those kind of things are widely used. These are the very high level drone usages. Yeah, so next getting to the IoT. What IoT the important mainly is.
The spread of counter-drone solutions. As drones become increasingly common, there is a greater demand for counter-drone solutions to secure sensitive places and prevent unauthorized drone use. These systems can identify, track, and reduce possible drone threats, protecting key infrastructure, events, and airspace. Anti-drone technology deployment is expected to grow in 2023. However, the emergence of self-driving cars raises worries about privacy and security. As drones grow more powerful and popular, the possibility of unauthorized monitoring or data collecting increases. To address these issues, governments and regulatory agencies worldwide are collaborating to develop standards and laws that balance the benefits of drone technology with the need to safeguard individual privacy and maintain public safety. Despite these obstacles, the future of autonomous drones is bright. As AI advances, we should expect to see more sophisticated and powerful UAVs capable of doing increasingly demanding jobs. Drones that can autonomously do infrastructure maintenance, carry items, or even move people from one point to another may become a reality in the coming years. Finally, the incorporation of AI into drone technology is defining the future of unmanned flying, bringing up new possibilities and uses in a variety of sectors. Autonomous drones will continue to revolutionize the way we live and work as they grow more capable, efficient, and affordable. We can unlock the full promise of AI-powered drones and build a safer, more efficient, and more connected society by embracing this technology and solving the issues it offers.
Yes. So yeah, why again I played this is like you can see the technology use. Of course, the drone is just a UI technology, UI system which can fly and which can capture it as a bunch of sensors. But on top of it, to move the drone technology next level, you need the communication has to be improvised, right? So how that communication will be improvised, the very first thing needed is a 5G. Okay, because right now whatever we are in the 4G internet world, the drone or whatever the efficiency is not sufficient. Okay, so as per the study, 5G is must needed to enhance the drone technology. Okay, so based on 5G, what is a 5G? Why we need 5G? So it's simple. Like you want the internet need to be faster. You want to process the data as fast as possible. Suppose if you are making a video call in earlier days, earlier to earlier, you might have seen it like even we used to pay for the video calls, right? And you earlier used to, you can't even send the video messages, but after coming the 4G, we are at least able to send a video messages. What happened in the 5G, it will be super fast. So basically right now, for everything to send every MB of data, it takes a time. Even if I want to send 1 GB today, it takes at least 30 minutes or 15 minutes. Maybe once the 5G comes, it reduces the time to maybe in 1 minute, I'll be able to send 1 GB of data from one network to the other network. Okay, so why we need it, what are the advantage of this? Because the whole, now the world is connected to the internet. Because without internet, of course, I cannot take this session, right? If you've no internet, I won't be talking to you from here, right? So but we want more advanced, right? What advanced can do, especially our banking. You can see even the banking right now use overall internet. The money handling needs to be improvised. If you see the transportation, the data, those all has to be made it faster. Same way when I come to the drone, you want the decisions has to be made faster via internet. So that's why the main communication for next generation, which will be taken care via the 5G, which will be the increasing the throughput. So basically any data whatever you will send it, it will be manipulated faster, and also the output what you can expect, which will be faster. Okay, and also the security purpose also. See right now, even the whatever you do, even the drone can be hacked, but with the 5G help, the drone can be encrypted and also it can be securely used. So yep, so these are the few points. Yeah, so you can see which I already spoke. So right now the estimator is 11.68 billion, the market size, but in 2032 it can go up to 28.38% of growth. That means 5G is already there, but the importance of this will be increased day by day. Okay, starting from the self-driving car. So I think you guys know already. So even like if I can go for another 10 kilometer or 10 miles from here, I see a self-driving car. So self-driving car, of course, it is fully autonomous, it's fully internet connected, right? So how that functions, if no internet, it cannot function, and it need a high data speed processor. So for that, they need an advanced internet. And also you see the smart city or smart home. Suppose when I go from my home, I want to control my home, I want to turn on my Wi-Fi, I want to turn on the lights, I want to turn off the refrigerator. So everything can be improvised with the 5G. And also you see the ornamental reality, so which is like if you want to see the increase the more virtual reality things, then you need the advancement in the 5G. So this is again I'm talking more on the communication side. We need 5G when we are talking about the internet of things. That's why I put those two slides. You might have already heard about internet of things, but today we are going to talk something more about internet of drones. Why we need internet on the drone? Mainly to make a decision making faster. So right now drone has its own chipset. It can make it faster, it can decide, it can detect an obstacle, it can take a route. But you want to do more operation. Suppose I want to detect a person in a drone, sorry, in a site, in a big gathering, which example I already gave. Or suppose I want to make suppose in the agriculture I want to make a fruit counting. There are a lot of things. So for that, to improvise that, we need a strong internet connection on the drone, so that will enhance the drone capability. So basically, see, the human, many things they cannot do it on air, meaning like suppose tomorrow one tsunami or any disaster happen, sitting in the ground station, we don't know what is happening there or what to do, we can't do it. But if we can send a drone can do it, can help you a lot. So that way you can increase the efficiency of your drone, so that the other side, whatever any disaster, can be recovered faster. It will help to save the people life and also help people to save the time and the cost. So that's where the technology comes to picture. That's where we all are, the whole world is working on internet of drone to make more drone communicated and make it efficient and also the more faster. So that's the whole idea of it. So Internet of Drone, what we needed. So first we need to collect the data. So to collect the data, suppose as I mentioned, even in our real-time project, first we are doing a data collection. So first, as a before we deploy anything using a drone, we collect the data, and also you reduce the reliability. So that means like making a mistake. So those all mistakes has to be trained by a drone the processor, and also we need to make the faster. So we want to make the decision needs to be faster. So for this purpose we need the stronger internet connectivity on the drones. So underneath is like a sectors. If once iod is there, the sector wise, like almost all the like search and rescue, military applications, and also wildlife, firefighter, agriculture, there are wider sectors which will be widely used. And as I mentioned, like the benefits, it's a lot. It's like a enhanced operational efficiency. It will increase the safety and also the other technologies. Basically, so right now, as I mentioned, like the AWS is one of the core component. Like that, there are many other technologies or processes are developed. With that integrations, the drone can perform more better. So, so that's what more about the drone. Any question on IoT?
Sir, in the IoD architecture, whatever you have given, yeah, here, this
Mhm.
architecture. So is it that satellite connection is the redundant one, or what is the
No,
loop
it's just a
here?
GPS, right? So basically a GPS coordinate, right? So it has a GPS, right? So in case of no internet also, we will be always able to track a drone, right? So that's why we have a GPS tracker. So the tracker will be able to communicate with the, not actually a satellite, at least we'll be able to get the coordinates. So that's how it is.
Sir, who will control this swarm of drones when they are flying autonomously? Like,
Good question. I can answer that. So yeah, so swarm of drone is typically a great concept. So we have we ourselves build the autonomous system. How it is built? Okay, so basically we have a mothership. Okay, so mothership is built as a main drone which will have a child inside it. Okay, nobody is going to control from the ground station. We will trigger from A to B, just go and do a surveillance. Okay, in case if you do any threat, you need to unlock your child and they have to go ahead and do a do a blast. Okay, so this all intelligence will be built on board computer. Okay, so the mother drones onboard computer, all the AI algorithms are written such a way that during a flight time, any threat, suppose it found the enemy person, it found the border. Okay, so immediately the one drone has to go ahead and blast it. Okay, so the mother drone will have the intelligence to release the child and it will just go ahead and blast it, and there is no internet connectivity here. You understood?
yes, sir, this is fine, sir. But a small doubt here.
Mm-hmm.
Hello,
Go
sir.
ahead, go ahead.
Sir, when you are having a swarm of drones, are they making a lot of noise when you use for border or military purposes? How people will reduce that interface, like noise generated by propellers and all? Is it taken care or how it is? They will
Yeah,
fly
yeah,
at certain rate.
of course, of course. I mean, see that noise part. There are a lot of what to say, the guard we call it. Okay, the propeller guard. Okay, and also the material what we use, it differs because see the swarm drones are called as a suicidal drones, right? So for that it has to be built such a way that it is functioning on the no internet zone and also the high altitude things. Okay, so the noise also it can be controlled when we use the extra shield for the propellers. Okay, one is that, I mean, right now there will be a noise will be there, but there are a lot of new motors are coming. With that we see the improvised very reduction of noises now.
Thank you, sir.
Thank you. Okay, so Sharan, we are okay, Sharan. I am ahead of time. Can I take 10 more minutes?
Yes, sir. Yes, sir.
Yeah. I'll wind up quick. Okay. Yeah. So this is when I talk about the next generation, even here in our day-to-day life, this is a very important piece. I feel it because this edge computer versus a cloud computer, I really want you guys to understand. That's what even I was talking till now. Okay, so quick shot about the edge video, you guys can take a look.
What is edge computing and why it matters? Edge computing is exactly what it sounds like, computing that takes place at the edge of corporate networks, with the edge defined as the place where end devices access the rest of the network, things like phones, laptops, industrial robots, and sensors. The edge used to be a place where these devices connected so they could deliver data to and receive instructions and download software updates from a centrally located data center or the cloud. Now, with the explosion of the Internet of Things, that model has shortcomings.
Sorry, I replayed, but yeah, I really want to speak something here. So yeah, so you guys can understand this, right? So you see this whole block, right? Why the edge computer is so important right now? So because we want to have a private network, because we don't want all the data to be available in the public. Okay, we want to have our own server, and from that server all our devices needs to be connected. Imagine I'm working in a company, I'm developing a project. We don't want that project or product to be interacted to the public, so we want to keep it within our server using our VPN connection or VPN. Within our private network we want to allow people to connect. So that's what called as a edge computer, meaning all the algorithm, all the powerful things, we want to keep it in a closed circle without exposing to the public, and make sure all the functionalities are working in the efficient way. Let's
Between
continue.
the data center or cloud and the devices. For example, if sensors and valves at a petroleum refinery detect dangerously high pressure in the pipes, shutoffs must be triggered as soon as possible. With analysis of that pressure data taking place at distant processing centers, the automatic shutoff instructions may come too late. But with
Yeah, you can see in this example they're trying to show, suppose we have a detector, the gas detector, it detected it, okay, detected the smell, but it has to take a decision right away to turn off the vacuum. Okay, so that decision making should be quicker, right? It cannot go to the cloud, it has to process, then it comes back, then by then the incident will happen. So what they are trying to say is, so the edge computer, the computation what we do, it should be on board, right? And the decision has to be as fast as possible. So that's where the edge computer comes to picture. So your all the algorithm, all your processing unit will be sit on the device, and it will be processed, and decision will be taken as soon as possible. So you can see here.
But with processing power placed local to the end devices, latency is less, and that round-trip time can be significantly reduced, potentially saving downtime, damage to property, and even lives. Even with the introduction of edge devices that provide local computing and storage, there will still be a need to connect them to data centers, whether they are on premises or in the cloud. For example, temperature and humidity sensors in agricultural fields gather valuable data, but that data doesn't have to be analyzed or stored in real time. Edge devices can collect, sort, and perform preliminary.
Yeah, so they are trying to say like that data persistence, because earlier I was saying the AWS, Lambda, whatever, the DynamoDB, but in case of edge computing, even we don't need the real database. They were trying to say it can be processed in our data centers. Okay, so imagine like in our sensor we cannot save much data, right? So they are saying those data can be pushed to our own network, to our data center, and that can be processed later in case you want for the future reference.
Analysis of the data, then send it along to wherever it needs to go, to centralized applications or some form of long-term storage, again either on-prem or in the cloud. Because this traffic may not be time-sensitive, slower, less expensive connections, possibly over the internet, can be used. And because the data is pre-sorted, the volume of traffic that needs to be sent at all may be reduced. So the upside of edge computing is faster response time for applications that require it, and slowing the growth of expensive long-haul connections to processing and storage centers. The downside can be security. With data being collected and analyzed at the edge, it's important to include security for the IoT devices that connect to the edge devices and for the edge devices themselves. These devices contain valuable data, but there are also network elements that, if exploited, could compromise other devices that contain stores of valuable assets. With edge computing becoming more essential, it's also important to make sure that the edge devices themselves don't become a single point of failure. Network architects need to build in redundancy and provide failover contingencies in order to avoid.
Yeah. So the only drawback what they're trying to say is, if our computing intelligence is sitting on the board, in case if that got impacted, then our intelligence stopped functioning, right? That's how it is, right? Suppose like if one drone, if I have the intelligence in the drone, if that drone is gone, then I have to send another drone. So that drone intelligence is gone. But if I keep it on the cloud, that is the other way, right? Because if you see, even though my drone go bad, my intelligence still might function. So that's what they're saying here. So even if the one device is gone, then your whole intelligence, until you replace the device, your intelligence can be active.
Crippling downtime if a primary node goes down. The industry has already gone a long way toward addressing the demands of edge computing, and it's becoming mainstream. Its importance is likely to grow even more as the use of real-time applications becomes more prevalent.
Yep. So yeah, so the edge computer, I feel like for the next gen communication, this edge computing is very, very important. As if all the college people or whoever the next generation people, they really know the importance of it and do the programming accordingly. So meaning now you might have seen the latency of the edge computing and also the bandwidth optimization. So these all has to be more efficiently done in the future. So basically, because right now we were doing it for a megabyte, maybe in future we may do for the microbytes or maybe the byte. So that way your programming computation will improve or increase the efficiency of the each devices. So you can see here the advantages: low latency, bandwidth, and also the improves the reliability. But the disadvantage is there, as I mentioned, like in case of no network, then of course like you have a drawback. You don't have a connectivity, and also the limited processing, because like you are connected to the connected small private network. If that network is gone, then whole system will go low. So this is one about the edge computing. And the same way, if you guys think about the cloud computing, so there we talk about everything the private, everything is a VPN based. Virtual network will be part of the secured for the one independent corporate, but cloud computing is totally different. That means you don't need to own any of your intelligence. All your intelligence is sitting in the cloud. Okay, so you do your program one spot and you provide the multiple interfaces, different devices, and they will just take it, they will provide an input and they will be wait for your response. So this way your devices tomorrow, it can be a number of devices, all your intelligence sitting in the cloud. That way you can avoid storing any data in the devices. Simple example is say your mobile phone. So your mobile phone, if no network, then all the data saved in it, it will be computed itself. Same way if you take any IoT devices, maybe if you're a drone, or if you take any other IoT, maybe the autonomous car, right? If you take autonomous car, if no internet, it can't even go, right? It can't even drive. So in that way, so the cloud computing in case of autonomous car, it is very, very efficient, because even if the drivers go sleep, it can collect all the data, it is stored in the internet, it can pull it back and it can make work for you. So that's how the cloud computing works, and it has its own dependency because it is publicly transported, and it has to be more secured, and also data latency will be there because it has to connect to the internet. So the always the connectivity issues will be there, and also data security, I mean like a data sensitive, because you are always keeping your data in the remote server. So this is a major difference between edge computer and cloud computing. And and the usage is based on your requirement. And with respect to drone, we can do both. As I mentioned, edge computer on board computation also can be done, on cloud based computation also can be done, but again based on the need. In case of defense, they don't prefer cloud computing, they want edge computing in the place. In case of agriculture, they are okay because they are always connected. Or in case of delivery drone, they are always connected to the internet, so that means they want the cloud computing in the place. So these all are so futuristic. So that means like in case of future drone, these both technology will be damn sure used. So for whoever the upcoming techie people, if you can focus more on cloud computing and edge computing, how actually work in the drone, it will be really helpful for you guys. So, yep, till now, any questions?
Sir, I have a doubt here, sir.
Mhm.
Sir, in companion computer, apart from Raspberry Pi, like in industry grade or military grade, what are all the other platforms that are used? And second thing is,
Mhm.
for military purposes, when you don't rely on cloud kind of communication, where
Mhm.
you prefer edge kind of thing, how will be that availability is provided? Some heartbeat kind of thing exchange has to happen, or any known case that you come across in this particular scenario?
Very good question. Okay, the first question, let me answer. So of course, see, we have a NVIDIA chipset. Okay, we have a Broadcom. Okay, we have an Intel chipset. Okay, so Raspberry Pi is just like one of the economical processor which we can use. Okay, but there are plenty of other processor. So based on NVIDIA Jetson is one of the very popular one which we also use it. Okay, again, it depends upon the usage. So what kind of AI computing you want to do, then you prefer and pick it. So answer to your second question. So in case of military, how the heartbeat, right? So because of course they're till today they are using the manual. Okay, right now they are not yet deployed any autonomous. Okay, so right now they are using a manual one because of the RF interruption and also the altitude issues. Okay, so once we go for autonomous, we tested in the certain altitude. Okay, what kind of heartbeat? Of course, because we always have a two-way of communication. As I mentioned, if we can little more go back to my architecture, let me quickly go here. Yeah, here I mentioned something like a here link, right? So this here link, the data transfer, the RF, it can ship up to 25 kilometers. Okay, but there are plenty of other air units are available, transmitters are available which can even give to the 100 kilometers. So here I don't need a companion computer, I can still get the heartbeat via the my here link or my other transmitters. You get it? So these are the recommended, mostly recommended for the, because even this here link what we used is for 20 kilometer, we demonstrated for one defense. They're very quite happy with that. Here there is no internet, nothing, no companion computer. Did I answer your question?
Yes, sir. To add to that, if we are taking a swarm of drones and
Mhm.
if you want to provide availability, then what they do? Like you have spoken about mother, I mean drone and
Mhm.
children. But if mother has lost subsequently,
Yeah,
uh,
yeah, 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 yeah. No, that exactly the one big drawback. I mean, even we saw it because if mothership has lost the connection or communication with our ground station, then we lost it. Then whole thing is crashed. I mean, that's why we were proposing instead of mother, you should always have a independent swarm of drones. Okay, so if you go for
The spread of
yeah, maybe, yeah, if you put here, right, so these all are the independent swarm drones, understood, right? So in case if one goes bad, the other one, so always that's way to perform a one operation they always send a four. Okay, so basically they try to detect the closest one. I can show you one video, let me see. Yeah, you understand what I'm talking about?
yeah, I got, sir. I got.
Yeah, so always it has to find the nearest. So basically we'll send the four drone, it will go, for example, take go, it goes for the four different corners, but because the enemy will be there anywhere, right? So if one drone find the enemy, it will immediately send the message to the other three drone, hey, I found it, if anybody nearby come as a backup, other two please go back to the home. Understood, right? So this way we are really safe and we are saving other two drones. You are right. In case of mother, in case of communication is lost, we will be lost. Yeah. Thank you. So yes. So final takeaways. What? Yeah. Go ahead, Boomer. Yeah, please.
Yes, sir. As a small question, sir. Um, Sir, how an UAV compared to this historical data for identifying and trends? Means what is the role of this automation play in detecting and deforestation like from an UAV data?
No, you mean the drone automation or autonomous? Autonomous is different from automation.
Sir, I'm asking about an automation, sir.
Okay, automation meaning how? Can you explain that?
So simply I'm asking, sir, how an UAV data compared to historical data for identifying the current trends?
Okay, so based on the data, right? So based
Yes,
on
sir. Yes,
the
sir.
previous data we collected. Okay,
Yes,
so
sir.
your question is more about the data training part, if I'm
Yes,
wrong.
sir. Yes, sir.
Yeah. Okay, so see, that's why we hire a separate people. So data engineer, what they do is they collect at least 1 million to 10 million data. Okay, because there are website, there are things available. Okay, where we go and collect the data. Okay, imagine like suppose a forest deforestation, whatever you said, related to that, we really go in depth and collect the data with the aerial footages. Okay, not the raw footage. If the aerial footage is not there, we literally send a drone to collect the data. So with the collected data, we try to process it.
Fine, sir. Thank you, sir.
Okay, thank you. Yeah,
Sir, can you share some URLs or resources links
of course. Yeah.
for students to explore?
Sure. Especially, yeah. I do have it. I will try to share it with the server for sure. Okay.
Thank you.
Yeah. So yeah, final takeaway. I really want to encourage you guys. I mean, drone technology right now, it's still, I could say it's an evolving path. Okay. Still, we are not reached even 20-30%, I feel, because we have just a flying machine right now. We didn't build any skill. All skill developments are still in process. We can say like 20 years before how mobile phone was there, that's how it is right now. Okay, but in another 20 years or 30 years, it will be a massive growth will be there in the drone. Okay, so as a career path, I really encourage you guys to take it forward. Okay, only thing is that's what, don't strict only to the drone flying as a pilot, or just assembling a things, or just getting to know more about the FPV drones, not like that. Okay, because the market, what it going to be trend in another 10 years, like 2035 or 2045, it has to be drastically different than what we are seeing today. Okay, maybe in future like 100% drone delivery will be there. Okay, and also the agriculture, right? In the agriculture, everybody has to use it. Maybe because now farming has gone to the different layer in even in other countries, because right now farming, like whoever the previous generation farmers, they can do farming for another 10 years, but after that, the recent farmer has to take it, our technology has to take care of the farming. Okay, so that's where I really recommend you guys, the future trend for drone is really good and wider, so you guys can focus more on it. My only request is that's what, like, I see many people, especially in our side, like they focus only on the hardware, they don't really focus on the other technology part. But this is really wider. I really want you guys to focus more on whichever I shown, like computing things or autonomous system. That's what, even in our architecture diagram, we were showing the end to end. You can see here, right? So you can see the autonomous flying, the fleet management, the AA, the sensor management, and also you see here the drone deploy and air map, AA image processing, security surveillance. So there is, you can see like here we listed very few applications, but there are wider, some more, a lot more applications are there. So I want you guys to think about the end to end, don't stuck at the hardware or something. So even you see the drone, we have varieties of drone, like we have a UAV, the fixed wing, we have hybrid VTOL, we have a heavy lift, and also the docking station. So the docking station is another huge R&D is happening right now, even starting from DJI, even the Skydio in India. So there are a lot of companies right now where from India, actually we are borrowing the technology from other countries, but within India we are doing a lot of R&D for the docking station. So you see today, wherever we see the gas station, we call it petrol bunk. In future, it has to be a drone docking station. So drone has to just fly, go get it charged, and it has to take off itself. So that is how the future is building, evolving. we can lively see here, of course, here, wherever, because I'm talking to a lot of people. So where I work right now, I'm working in autonomous car. 10 years before, nobody would have thought like, oh, the car can go itself without a driver, right? But now I drive autonomous. So in Tesla, like, you just put a full FSD, then it just go itself. I don't even touch the steering, I don't even do anything. So that's how the evolving is happening. So just focus on the technology on the wider area, so that it will be good for your future, guys. So yeah, with that, yes. So with that, yeah, I like to give 5 more minutes for any Q&A, Sharavnan.
Yes, sir. So participants, you can directly ask a question. You can unmute and ask a question to our resource person, or you can put in the chat box.
Yeah, you can put it in
Sir,
the
I
chat.
have one question which is in my mind for a lot of days.
Tell me.
When we will get a drone in India like DJ, sir, to replace DJ, especially with respect to videography and photography?
Yeah, I mean, like, you have a lot of people turning, but you should have made by now. I'm waiting a drone from you, your team. You have a lot of talent pool in the college. Like, you guys can make it. Why you are using DJ anymore? Right?
Uh,
Right.
we are in the process there, but it takes time. It involves a lot of
Yeah.
financial, technology, sensor fusion, and something like that. So
Yeah. No, it's to answer to your question, of course, like, even my eagerness is that, like, we literally stop using the DJ and other country drones. Okay. But where we are lagging, I should say, stopping, as you said, like, infrastructure first of all, right? So for us, like, infrastructure and investment is the biggest point. People, government supports, yes, I should say yes, but again, whether we have all the necessary components in India, no, right? We have to get it from outside. Again, the component, we don't have all the component manufactured in India right now. Few companies we are able to manufacture even the batteries and everything, but still our ecosystem is still, we are evolving with respect to drone, because even in US, because kids fly the drone, kids able to assemble a drone, it's like that, because they have everything is for cheaper here. So here, if I give maybe 5,000, I can make my own drone. Understood, right? But if same thing in India, it is like a more expensive, not available, or people will say it's like a toy, waste of time kind of thing. So to answer to your question, India is coming really fast. Right now we have a lot of RPTOs, lot of approved companies are coming. But only thing is, until unless we are just relying on other country to send us a hardware, that will be there. Okay. So once that is getting stopped, once we have our own sensors, we have our own hardware, then it will come as a DJ. Like, that much testing also needs to be done, right, Sharon? Because our right now testing ecosystem usage, nobody trust if it is our own build. If I say like Astro Aerospace is selling a drone, nobody will have a trust, because do you guys, how many times you tested whether it will fall from sky, what happens, kind of thing, right? So so that trust still, people should believe first. So it takes some time. Hopefully in another few years we will hope, Sharon.
yes, sir, we'll think about it, sir. Yes. So there is a
Yeah.
question, sir, in the chat box. What are the open source tools that can be used for building multi-purpose software stack?
Okay, very good. Yeah. Oh, open source tools. Yeah, I can share the reference for this. Let me take this question. I do have it. Let me take this question. Yeah, I can share you, Sharon. There are a lot of things. I mean, right now we use Pixoc. If you guys know, you can just Google and say PX4. Okay, there is something called a PX4, which is a firmware which is used, one of the open source, which you can use it. What else? And then for Raspberry Pi also we have, and also the QGC, we call it as a Q ground control. That is also a one more software stack which is be available for the ground station control. Yeah, but I can send you the reference for these two. So right now we use Pixoc 4. You just go on Google, just PX4 open source. You'll get the GitHub link. You can download and you can build your own code. We do have it in Astova. We have our own GitHub with our all open source things.
Okay, sir. Yes, sir.
I can share this. So yeah, this is our repository. You can see our, let me see our QGC, right? So if I go our Q ground station, yeah. So this is our repository for ground station. Yeah, this is our open source for the ground tool. So similarly, we have our AA tool, and also the PX4 also. So you can just go on Google, it will come. Yeah. If you want, I can share it with Saravnan.
Yes, sir. Yes,
Yes, sir.
sir.
Okay.
We can wind up time to 3:30. Yes.
Yeah, hopefully any other questions? I hope I fulfill Saravnan and team and whoever attended
Yes.
because it was a little bit short notice. I mean, like whatever I could, I prepared it. I hope it was a very useful session to you guys. And yeah, you guys can follow me in LinkedIn, and also you guys can like or subscribe our Astro Aerospace also because that's where we'll be keep updating on what we are doing. So and you can
Thank you, sir.
share my LinkedIn. Okay.
Yes, sir.
So yeah, if anybody interested, you can follow and then the Astro Aerospace also.
Yes, sir. Yes, sir.
Yeah, yeah,
Thank you,
you
sir.
can.
Hope to see you soon in our Hindustan, sir. We'll do one more drone championship near future, if possible.
Okay, yeah, yeah. Sure, sir, sure, sir. I know you are keep interested. Yeah, for sure. I will talk
Yes.
to. That's part of Skywalk. Yeah, even I used to do that for sure.
Yes, sir. Yes, sir. Thank you so much, sir.
Thank you, everybody. At least give me a thumbs up before you go in. Everybody should give me a thumbs up.
The participants, you can turn on your camera so that it will be helpful.
Oh yeah, that will be great. Let me stop sharing
On
too. Yeah, I'll stop sharing and everybody say hi. Thank you, Aboma. It's a good session. I mean, like, thanks for your questions. It's really encouraging.
Yes,
Thank
sir.
you.
Thank you,
Thank
sir.
you. Thank you, everyone. Thank you. Sir. Thank you.
Participants, we'll take another 2 minutes and we'll be joining by the second resource person. Yeah, it is it is a long day today. It will be a lengthy session or lengthy day for to all of us. We'll be completing exactly on no, around 6:30, and then from 6:30 you can start your assessment through the portal. We'll start this second session for today in another 2 minutes.
Sir, one request, sir.
Yes, sir. Please, sir.
Sir, if possible, give some 10 to 15 minutes time after the sessions, sir. Because continuously listening to these sessions and taking tests, it could be a little bit.
Right, sir. We'll try to complete by 6 so that you will get an half an hour time so that you can
Yeah.
refresh and you can come.
Yes, sir.
Yes.
Thank you.
Thank you. Thank you, sir. Thank you. Good afternoon, sir. Yes, sir. Good afternoon, sir.
Good afternoon, bro. This is Saravanan. Can you hear me?
Yes, sir. Yes, sir.
Okay.
Shall we start, sir?
Yeah, ready.
No. So again, good afternoon, professors. We have joined here for the second session, which is going to be handled by uh, Dr. Bruce Reflin Rose, Associate Professor of Mechanical Engineering Department from Anna University Regional Campus. Delivered a session on AI-powered drone systems. So I would like to welcome him and I would like to hand over the session to him. Yes, sir.
Okay, sir. Can you see the screen now?
Yes, sir, it is visible, sir. Yes, sir. But not maximized, sir. Maybe.
1 second. Let me try. Is it okay now?
Again, it is not on full screen mode, sir. It is.
Okay.
No, so there is no change, sir. It is still the same. Not in the full screen.
Is it okay now?
Yes, sir. Yes, sir. It is fine now, sir. Yes, sir. Yes, sir.
Okay. Very good afternoon to all. And now it is my second session. And in the previous session, I have summarized about the different AI applications, AI-enabled systems of the drones, and I have mentioned a few important points in that how AI is going to impact this particular drone technology. Now it is a more generic and more generalized topic. So I would like to summarize it as early as possible. And as your organizer told, you have some assessment and other requirements also today. So here innovative applications of drones. And my presentation is going to be again in a multidisciplinary perspective. First, the very fundamental thing, that is what are unmanned aerial systems. I hope you are already had excellent sessions, and you are now very familiar with this term. Aircraft without a human pilot on board, basically UAV. So it is either controlled autonomously or else under the remote control of a pilot. Now, why I am repeating the definition of what is UAS here is based on this statement, either it is autonomous or it is remotely controlled. You can customize your innovative applications. That's why again I am emphasizing the point here. And other names in this presentation itself, I am going to use some different terms to define your drone. That is RCV, RPV, and ACV, like that, autonomous control vehicle, radio control vehicle, remotely piloted vehicle. So don't confuse with the term. Obviously, it is the other versions of your unmanned aerial vehicles. Okay. And now, before getting into the first of all, you just re-examine yourself. How many of you are having drones, or maybe among your family, someone is doing it as a hobby or research or something else. And how many of you operated one? If you have already, how many of you operated? And how many of you got license to do that? How many of you got the trainer license? All these things are very much essential in terms of getting into a specific application. For example, if you are a licensed person, you can utilize your drone towards some innovative application. And if you are not yet licensed, you may not be allowed to perform the task with your drone. And sometimes if you are a licensed trainer, you can do some, you can carry out some application, you can use your drone for some application, and maybe if not, you are prohibited to proceed with that. Okay. So in this presentation itself, I am going to give more focus on agricultural applications, because in India now the drone rules are relaxed towards primarily for agriculture and military applications. So as a faculty or student or young researcher, there is wide scope exists for your drone applications with agricultural activities. So around 50% of my presentation is in aligned with agricultural applications. Now, according to Merriam-Webster definition, it is a uncrewed, unpiloted aircraft or ship guided by remote control or onboard computers. Why I am giving the statement ship is, in the previous presentation itself, I have mentioned about autonomous underwater vehicles, that is underwater drones. Again, you remember, it is applicable for those applications also. And the types already you are very familiar with, fixed wing, VTOL capabilities. Even for hybrid models, you can have a VTOL with STOL, short takeoff landing capabilities, aerostats, and the sizes also large, medium, small, micro, nano. So why I am recalling these basic definition and category sizes here is, you should know, you should remember the size of the drone, and how it is categorized according to the weights. What are the drone regulations involved? All those things. I hope you are had some. You are familiar with through some previous sessions. That's why I'm not repeating those things again. But these different categories determine the specific applications of the drone. Okay. So now you are assume you have a drone, and how you are going to use your drone with the fusion of new technologies, whether you have micro sensors, whether you have firmwares, softwares, new modulation methods, GPS, outrunner motors, lithium polymer, lithium ion batteries, lightweight materials. So for example, if you are using a survey drone, which is generally used for specific photography, aerial photography purposes, or simple surveying activities. If you want to add some specific feature in the payload, maybe you are adding some lens, or you are adding some gimbal adjustment, some additional accessory with that, without disturbing the major components of your drone, how you are going to increase your payload? Maybe there is a compromise with the battery endurance. Maybe you can have reduced mAh battery. Originally it was 40 minutes. It was operated for about 40 minutes, means now you can reduce it for you can select a battery with lesser size, lesser weight, and you can restrict your endurance to 20 minutes, and you can add up some payload. So likewise, you can customize your drone according to your requirement, based on batteries, based on the systems you are using. Whereas these softwares and AI driven tools are primarily concerned with safety and security and other primary concerns. So in that part, it is not possible for us to customize. For example, if you are a person from computer science, maybe you are using different open source, or you are using different softwares to retrieve the data, or you have different softwares to operate your drone through GCS and all. It is extremely difficult to customize it instantly, whereas if these mechanical hardwares and other cosmetic settings, you can easily customize in order to adapt your drone for a specific application. That's what the fusion of new technologies with the drone components. So that's why you can see nowadays it is not drone development and drone research is not vested only with aerospace companies. It is with Google, IBM, Apple, and everyone else. So the sizes today determine the payload. Obviously, the payload and the size of the drone determines your endurance also. So if you have a x-axis, if you have endurance in x-axis and payload in y-axis, you can arrange the types of drones in this fashion. Here it is gas-powered VTOL, gas-powered fixed wing, electric VTOL, and electric fixed wing. So with this perspective, I'll just show you different images of these categories. Here you can see the large drones, which are primarily used for military purposes, Predator and other models. This one is a gas-powered drone. It is originally operated with the concept of a airship, and IIT Bombay, they are doing extensive research on airships, and if you use these airships which are filled with your helium or any lightweight gases, it can be used as a effective tool for your drone technology, because uh, 24/7 you can utilize it for surveillance. You have extremely high endurance, and you can customize it for various societal applications. Then in the case of medium category, we have different types of drones, single rotor drone, and string takeoff type drones, and hybrid type drones. And for small category, mostly it is available with even nowadays with startup companies. They are customizing the small drones for various applications. And these are the micro category drones. So already I have some brief summary. It was delivered during the previous lecture about pollinating drones. So those drones are coming under micro category here. And the special purpose drones, especially the agricultural drones, even in that the drones with specific payloads for variety of applications. So it can, for example, if you are talking about the agriculture drones, it is capable to count and determine the size of the plants, measure the plant health both quantitatively and qualitatively. It will give the result, generate prescription maps, and zonal efficiency of the fields, detect early indicators of plant stresses and livestock and health and weight gains. So identify damaged fencing, access storm damage, calculate grove maturity, determine optimal foraging area. So all these farming related activities can be performed with the help of a single agricultural drone with variety of payloads. So about pollinating drones, already I have summarized about it briefly, but in this session we are going to discuss a little bit more in the horticultural industry perspective. And we know Walmart has filed a patent for robotic bees that would pollinate the crops just like the real insects. And this patent outlines how tiny autonomous pollination drones would use sensors to locate the crops, transport pollens, and verify which crops have been successfully pollinated. However, here the endurance is a real challenge. Already I have mentioned about the weight category. So within the very meager weight, you have to make the technologies are adaptable and workable within the robotic bee structure. So it is a little bit complicated to do that. So nowadays we are using indoor drones for mass pollination process. I will share the content in the subsequent slides. But as of now, pollinating drone is our robo bees is a crucial industry where the horticultural people are really looking for, and it would be significantly more efficient way to pollinate the crops than the crop dusting, because we know the pollinating drones can monitor the crop health and its aging patterns as well. So aging pattern, determination of this aging pattern is another essential thing in the case of fruits and vegetables, because nowadays, for example, if you are talking about banana cultivation, except the experienced farmers, most of the youngsters, even they are from farmers family, they don't know exactly when it is matured and when it is completely grown in order to go ahead with the harvest and all those things. Even the youngsters are not aware of it. So if you need a well-defined AI-driven software or data set in order to automate these pollination and crop health monitoring process in the near future in order to ensure the food security. So automated crop scouting software uses your phone to fly the drone, so automatically collecting data at key points in your field. So it is capable of distributing the pollens at a specific rate across the specific broad strip, and it is not only applicable for open space. We can use it for indoor applications also, and it creates this crop scouting software has the potential to create the field reports very similar to our your summary reports, what we have generally in our academic activities. This report immediately specifies the age of the crop and what kind of vitamin deficiency is there, all those things. Okay. So this data can be further processed for specific requirements according to the specific industry. So in this context, I would like to give some specific applications. So if you are working on a final year project or research, or you are from any different engineering department, you just determine which application is more suitable for you. I will just summarize it one by one. Fish and game monitoring, oil pipeline inspection, electrical wire monitoring. So most of the applications are self-explanatory, so I'm not giving any specific explanation on that. So infrastructure inspection includes your building construction, large scale bridge constructions, tower constructions, all those things coming under this infrastructure category, and laying of new railway lanes, tunnel construction, all those things. Then searching for natural resources, wildfire detection and suppression. So wildfire detection and suppression is a very crucial application, and most of the forest officials are really need of this particular application. And if you are able to develop a user-friendly wildfire detection application, it is more useful for the society right now. And storm and natural disaster damage assessment. In this part also, earlier most of the compensations given to unsuitable beneficiaries in the earlier disasters. So if you are using the drone technology for natural disaster damage assessment, it will be more precise. You can take the exact survey numbers which are affected, and you can exactly determine how much crop damage is actually there. So according to the damage level, we can fix the compensation. It is both win-win situation for both policymakers and farmers. And man-made disaster damage assessment. So oil spills, for example, in the recent times also, one ship accident. It was resulted with excessive oil spills. So you can easily assess the man-made disaster damage. So how far it is extended, and accordingly we can determine the penalty, and accordingly we can take the preventive actions. So all those things, it is extremely useful for all those things. And now environmental change detection. So here also floods, ice flows, soil erosion, recent Wayanad incident and other Trivandamala incident. We can take the preventive measures through the soil erosion studies, the results of the previous floods and all those things. Then flood potential monitoring. So we can take preventive measures through flood potential monitoring and meteorological studies. Then aerial video and photography. So in the case of a tourism industry, we can use this technology extensively. For example, in most of the tourist villages, tourist spots, so basically it is very inaccessible to the tourists to see the original beauty of those locations. So what we can do is we can use FPV drones in order to have a enthusiastic photography enthusiastic people to, within a marginal charge, we can use FPV drones to enjoy the complete view of the particular tourist village and all those things. Then traffic and crowd monitoring. So if there is a VIP visit, and or if there is a local religious festival, or if there is a riot, whatever the case may be, we can regularize the traffic and crowd through the drone surveillance. Then small package delivery, and most of the Amazon, Flipkart, and other online platforms, now they are really looking for this particular permission for small package delivery from their warehouses to specific points or specific regions. So why I am saying the term specific location or specific region, in the sense the delivery of these small packages to individuals or individual homes, it is really risky, and there are so many legal issues involved. So what they are asking is from a specific warehouse to some specific point. For example, if you are having a ATM like environment in your town or in your street, they will deliver it over there, and through your smart card or any other QR code scanning system, you can pick up your material. So in that way, they are trying to make it easier to deliver the things to different cities. Then terrain mapping and surveying. It is obviously a challenging task, particularly the surveying task in regions like regions with mangroves or regions with extremely hard terrains. It is very difficult, and construction site survey and monitoring, that is another more advantageous thing. Environmental monitoring, archaeological department, volcanology, volcanic eruption and all. Then atmospheric monitoring and measuring, hurricane monitoring, environmental rule compliance. In the case of environmental rule compliance, the AI-driven drones going to be a game changer in the recent near future. So you can see who is the real culprit behind a specific water body pollution, or who is the real culprit behind a specific air pollution in a particular region. So that can be easily captured through these advanced drones. So in the context of environmental pollution and control, definitely this environmental rule compliance application is going to play a crucial role. Then radiation measure and atmospheric sampling. In the end of presentation, I will show you how the gas sample measurement, radiation measurements can be done with the advanced drones. Then search and rescue, even Tamil Nadu Fire Service Department now asking for the particular rescue drones. So maybe if a person is suffering in a crucial spot. If you are able to supply a float, simple float itself could save his life. So it is very easy for us to throw a float or give a emergency material to the particular person. Then tunnel detection, protection from manipulates at large airports. Then charging wireless devices, airborne Wi-Fi, and communication relays and temporary communications during outages. Then coastal monitoring. Coastal monitoring is a really challenging task, especially in the case of our country. Specifically, we have a large coastal region. Then mineral detection, avalanche monitoring and rescue, mining applications. So here, almost around 30 applications, 30 plus applications I mentioned here. Out of these 30 plus applications, definitely few applications are very crucial for mechanical engineering, very crucial for computer science and engineering, very crucial for electrical and electronics. So that's what I mentioned in the beginning of the slide itself. You just identify which application is more suitable for your domain. Then accordingly, how the particular application part can be extended towards research, extended towards your vision, towards patents, decent number of publications, all those things. And now, as I told you, I would like to give a strong focus on this agricultural applications of the drone. Here you can see first the roles of drones in agriculture, soil analysis for field planning. So first, in a specific geographic location, what kind of soil is there? Accordingly, you can decide your crop. Even in nowadays, the young farmers are not aware of particular plant is more suitable for their region, more suitable for the soil, all those things. So if you are doing the soil analysis, it is easy for you to customize your garden. And planting, then crop monitoring, pesticide spraying, irrigation planning. Irrigation planning is crucial because nowadays, you know, the micro irrigation and there is Department of Horticulture, they are giving subsidy for micro irrigation process. So if you are, yeah, for example, if you are having some 50 acres of farmland, it is extremely difficult to assess the overall material requirement and the subsidy requirement for a particular smaller marginal farmer to apply. So it is with the help of drone technology, it is much easier to customize the irrigation planning. Then health assessment, controlling the weed, insect, pest, and diseases in the crops, and crop biomass estimation, scaring birds, and man-animal conflict. So let us see some of these applications in detail here. First, the spraying drones. Basically, you know, it is very easy to control because now most of the women self-help groups also enabled with this spraying drone system. So it can be operated over mountains, hilly terrains, especially in the case of coffee and tea estates. We can use the drone in order to perform the spraying activities, and highly wetted regions where it is inaccessible, and optimal usage of fertilizers and pesticides. That is obviously it is a labor intensive task, and it really causes severe damage to the health of the farmers. So optimal usage of fertilizer, and sometimes the manual computation leads to excessive usage of fertilizers that will spoil both your plant and the soils. So optimal usage is a crucial thing, and pesticide usage also. Then this less water requirement for spraying activities, that is another crucial advantage. Then increase in production or yield through a detailed coverage of spraying. And mostly, if you see these spraying drones, it is the maximum endurance of these drones with 10 to 12 liters of can, and 10 to 12 liters of storage tank facility. So it is the endurance of these drones maximum 20 minutes. So if there is some optimal change in wind patterns, it will be around only 15 minutes only. But within the span of 15 minutes, you can cover a large portion of your land. That is the crucial advantage. And the spraying will be more uniform and more even. So obviously it is uh, comparing with the manual fertilizer pesticide spraying activity, these spraying drones are extremely useful to reduce the time and less water requirement. Then in terms of precision agriculture, so basically the word precision, you know, it is in Tamil it is tulyam ana vyavasayam. So precision agriculture is very much essential. Here it is here we use a term ND one second. Sorry, NDVI, normalized difference vegetation index. So this normalized difference vegetation index is a very crucial parameter to determine whether you are really doing a precision agriculture or not. So this index, if it is green, it indicates the healthy plants over the region. If it is little bit shaded, it is not brighter green means the plant health, it needs a serious attention towards some nutrition side. If it is a little bit red in colors, then instantly you can recognize that there is a scarcity of water in the particular piece of land. So likewise, with this simple aerial mapping, you can customize the water requirement, pesticide requirement, nutrition requirement of your plant. Okay. Then with the with this perspective, students will be able to describe the applications of drone in horticulture and plant science related fields, and they will be able to evaluate a map and identify crop concerns. Okay, so obviously drones lend themselves well to the concept of smart agriculture and precision agriculture. So it will improve the productivity and reducing the pollution and reducing the cost associated with the crop analysis and crop inputs. And here let us start with this crop health. Here you can see that drones and UAVs can be used to help the crop grower on the ground gather important information from above and from angles that are typically not easily performed. Sometimes if you, for example, if you are doing some visual inspection in a banana tree, from our point of view, we'll check up the junctions of the leaf, and we'll check up check up the stem in a 360-degree viewing angle, and we'll confirm that if there is no visible pest or if there is no visible insect, instantly we'll conclude that it is in a healthy status. But if it is viewed from the top angle, if it is viewed from the some other side, maybe there is a insect attack, but it is may not be visible when you perform the visual inspection. So in the case of crop health monitoring, we can use the drones for direct imaging and snapshots. So it will give the real-time information, especially in remote or not so easily accessible areas. In most of the wetlands, it is not so easy to do the visual inspection. So we can get the reliable data from the not accessible regions, and the use of different imaging systems are beneficial for fulfilling these precision agriculture requirement. So the use of drones can help to identify the beginning of pest outbreaks in the very early stage itself, and it is more easy and quick, because once the pest outbreak is identified, we can proceed with spraying activity with appropriate pesticides. Then this can allow the farmer to grow the crops potentially at potentially reduced cost, and the amount of inputs also can be reduced, and reduction of crop loss. So the in terms of the input, it is very much essential, the term input. If you are identifying the insect after some after a couple of days or after some 1 week of time, it will end up with a huge crop loss. So if you want to have more information about this precision agriculture activity and early detection, here you can watch this particular video, that is using drones to save on pesticide cost and loss. It is a more interesting video. And in order to conclude whether your crop health is perfect, 80% or 100% or 15%, the index NDVI is a very crucial parameter, normalized difference vegetation index. So one application for drone use in horticulture and plant size is a crop growth and development. As I told, these application can assist in developing precision agriculture practices. So if the NDVI index is more green, then the better. The greener plot means the plants are more active. So here you can see wherever the plants are more active, it is 80%, 100% like that. So when there is inactive plant, there is an inactive plant 15%, 30% like that. The NDVI index is reduced. So, and based on the wavelength perceived, the information can give a grower, producer, or farmer a very good idea of how their plants and crops are growing. So, particularly if you are a small farmer or marginal farmer, it is comparatively easy for you to get a information. But it is a large farmer with 50 acres or 100 acres or 500 acres of land, it is practically almost impossible to get this information quickly. So this NDVI information for large farmer is supporting in many ways to achieve reduced crop loss. And here you can see the benefit. Another benefit is watering, fertilizing, pesticide application, harvesting. So all these activities can be well monitored and controlled. That results with the smart agriculture or precision agriculture. And maybe for a specific field, if it is a paddy field or a banana farm or a lemon tree farm or wherever it is, you can assign this activity for a class, or you can assign this activity for a PhD student, and you can ask them to get the image data and analyze it to study the NDVI in the particular field and how far it is accurate. With the help of the AI-driven tools, how you can characterize the field with accurate data. How far it is accurate with agricultural department field report and your drone technology based report. You can study the comparative data, and you can have a good number of papers with different fields. Then you can, if you are interested to watch this video, also drone video of Rocky Ford Tough Grass Research Center tour. This one is another wonderful material to read. Then in the case of precision agriculture, we can talk about greenhouse and orchard pollination. In the previous slide, I have that is before previous slides, I have mentioned about the pollinating drones. Here you can see there is a pollen source with this with this pollen source, you can achieve orchid pollination process. Here, the drones have been developed and modified to assist in pollinations, and drones can fly over the receptive flowers and drop pollens from the pollen catch. So, from this pollen catch point here, it will drop pollens, and in protected environments, there can be often be deficiencies in two methods. Sometimes, if it is inside the greenhouse, it is extremely difficult to achieve complete pollination. So what we can do is, where there is reduced wind and reduced insect, so from the if you are operating a drone, it can hover and create the wind, and when the pollens are dropped from the particular dropped over the receptive flowers, it could function as a natural pollination process. So it increases the potential yield in the protected environment also. So inside the greenhouse also we can enhance the yield. And the plant inventory and crop status. So drones can assist with the plant inventories and have been shown a decreased time needed for what can be a tedious task. And depending on the imaging methods and program used, multiple types of data could potentially be collected during the drone launch. So these imaging methods and programs, it is another important thing. How you are capturing the image, how you are collecting the data, that is very crucial, because each and every pixel matters. For example, if you are capturing a paddy field, the pest outbreak may happen from a piece of land. Maybe within a span of 1 cent, a pest outbreak has started. So if you miss the particular point, before your next evaluation, it will be spreaded over 1 acre or 2 acres of land, and afterwards, maybe though you use the effective pesticides, it may not be controlled. So imaging method and programs very crucial, and I hope regarding the software programs already you had some good sessions. But imaging method, that is another important thing. What kind of camera you are using, from which altitude you are operating the drone, and whether you are selected a most appropriate drone model for the particular activity. All those things are very important. And for inventory and crop status, in the case of plant inventory and crop status, it is completely connected with the commercial side also. So if the farmer is getting financial support from the government, and he is continuously watchful of the crop status, end of the farming activity, whether it is a win-win situation, that is very important. So if it is end up with the loss because of poor crop status monitoring, it will affect both the farmer, and it is a revenue loss for the government also. So crop quality and potential nutrient deficiencies and pest problems could be analyzed at the same time, and it should be more reliable also. Then evaluating the plant diversity, so understanding the plant communities. So it is also another crucial advantage with drone technology. So here it is, plant studies on the ground can be costly and labor intensive, especially in the rough terrains, and also some plants, especially endangered or protected plants, and the habitats they are growing in are delicate. So thus it is more practical to observe and take data from the air if possible. So endangered and protected plants monitoring is another crucial activity, especially in the in our state, Sadhyamangalam region and all, sandalwood and other endangered species are there. So all those crucial parts where they are growing are delicate, and it should be observed continuously. And if you are taking the data through the drones, it is more helpful for the different forest department, environmental department, and other industries, those who are needed with that, and works especially well in habitats with low vegetative cover. So here you can see other few crucial applications: chlorophyll concentration, bug infestation, fertilizer concentration, feedlot inspection, peak harvest. So these are especially when you perform through manual activities, it is almost impossible to study, especially the chlorophyll concentration and all. Though a educated farmer is doing the activity, even he cannot recognize it in a appropriate time. Then this is greenhouse crop monitoring. So drones are being employed in greenhouse settings and inside the control atmosphere. So potential pollination practices and actual insect control are possible. So about these greenhouse pollination and all, you can watch these two videos. That is bat-like drones for insect control and monitoring food in greenhouses and micro drone with the micro drones. Because of the time limitation, I'm not able to play these videos. Otherwise, I thought of play this video and pause it somewhere and to explain the crucial part of the application. So now altogether, what is the agri-drone bus? So advantage side, we can say it saves labor and can be operated by one or two people to achieve large scale farming, less intrusive practices for some situations and efficiency and all. But what about the cost? Now, if you talk about the agri-drone, maybe if you are having some 5 acre or 10 acres piece of land, you need to buy an agriculture drone. The drone cost itself, it comes around more than 4 lakhs. Then again, you have to, I'm talking about 10 liters, 12 liters of storage tank agriculture model. So again, third party insurance is there. Then tax and other things. Altogether, it will be around 6 to 6.5 lakhs investment needed. Then you need proper training to operate that, and fixing timeline, and the accessories associated with that. For example, if your flight control is malfunctioning, is it possible to service locally? For example, if you are having a KX or V5 flight controller, sometimes may not be possible to troubleshoot also. You need to replace it. For V5 flight controller, it cost about around 60,000, 60 to 65,000. So even for KX, it comes around 32,000. So the cost of the flight controller itself, yes, it will cause a serious damage to the farmer. So the disadvantage side, we need to make it is easily available, serviceable. All those requirements should be satisfied in a short period of time. Then only the usage of agri drones can be liberalized to small and medium farmers. Rather, only it is now used by the large scale farming side. Then I can say many other disadvantages also associated with these drone accessories and softwares. Then mining industry. So especially when we talk about mining industry, whether it is as per the norms they are proceeding or there is illegal mining happening and all, it is easy for the policymakers to inspect and proceed with appropriate penalties and other things. Then aquatic drones. So it helps to capture the underwater footage in seas and oceans. So underwater exploration, filmmaking, ship inspection, scientific research, and more. So here it is optical optional systems and sensors used in the underwater drones. It is again expensive in nature. And another major difficulty associated with these drones is a communication system. So mostly these underwater drones are tethered in nature. So when it is tethered, deep water investigation is extremely difficult. Only it is now used with the shallow water environment. Then even for that, we can use these solar powered AUVs, and here you can see there is a solar panel, 100 watts solar panel, and here you have panoramic camera. So it is useful for your underwater photography and filmmaking and scientific research activities. You can utilize this simple device as a AUV. So we can get excellent marine data through the underwater drones. Here you can see. Okay, as a concluding remark, I would like to give how the different industries utilizing the drone technology for precise measurements and accurate financial data development and reduced liability, improved worker safety, and all. So power line inspection is a primary application now. Mostly, in the case of abnormal weather patterns and rains in the middle of the night, what happens is a power outage, and it is extremely difficult for the electricity TNEB officials to inspect each and every line, and we can restore the power as early as possible with the help of drones for the power line inspection. And wind turbine blade inspection. So for potential structural failures and potential wear and corrosion problems, all those things can be detected with the help of drones. Here you can see the detection of dark areas, detection of hidden defects and failures, detection of erosion and corrosion. Especially in the case of Jaisalmer, Rajasthan, what happens is the blade surface is subjected to sand erosion. So we can examine all those abnormalities with the help of drones so that we can proceed with minor maintenance or major maintenance needed. And accordingly, we can plan our scheduled and unscheduled maintenance of wind turbine blades. Then for emergency purposes, emergency services, we can utilize the drones in order to take the emergency measures and rescue activities. Then for law enforcement, it was in the beginning I have mentioned about different security and military applications. So for different law enforcement activities, we can use the drones effectively. Then for bridge inspection, wherever it is inaccessible, especially in the Pamban, in Rameshwaram district and other different crucial locations, we can use the drones for periodic bridge inspection. Then disaster assessment, very similar to crop inspection and damage assessment, we can proceed with the disaster assessment also for both preventive and post-incidential measures. Then waste management. So drones with AI software can be used for mining outfit, insurance firms, and waste management companies to collect the information. And collecting the garbages, protect the marine wildlife, traditional labor-intensive activities can be reduced with the help of UAVs, and this UAVs can also be employed to monitor and inspect locations for any illegal dumping on industrial waste. These these unlawful practices can be captured and used as evidence against those committing the particular crimes. In a broad perspective, we can say for utilities and power, we can inspect hydroelectric plants, we can inspect solar farms. Here, first you can inspect the solar panels and you can easily detect the faulty panels. You can replace it. Even with the help of spraying drones, you can clean the solar panels effectively without any human intervention. And for construction site, you can utilize the drones for roof inspection and building inspection, quality evaluation, then urban planning activities. In the case of mining and aggregate side, you can estimate the volumetric stockpile measurement purpose we can use, and slope monitoring purpose we can use. within the uh, pipeline inspection, we can use the drones. Tank level measuring, refinery flat tip inspection, and for public safety search and rescue, for firefighting, situational awareness and monitoring, even to give a alarm or warning to the crowd, you can use the drones over there. And for agriculture, I have given a detailed information about it. And for research, especially the GIS studies, we can use the drones now, and wildlife management. However, for GIS purpose, simply I am saying you can use the drones. But as a young researcher or faculty, you should know that this is the GIS 320 optical gas imaging camera. It can visualize over 200 gases that are invisible to the human eye. But the cost of this FLIR Workswell GIS 320 is around 26 lakhs actually, along with the software. So that is the way the payloads what we are going to use for your application play a crucial role in the case of drone application. For example, if you want to use a thermal imaging camera to inspect your wind turbine blade, the cost of the camera will be around 6 to 7 lakhs. So the cost of the drone will be less than 2 lakhs, but the payload cost will be 6 lakhs. So that is the most important point where whether the professional who is using the drone, whether he is aware of the perfect operation, whether he is aware of the drone rules and activities, that is most essential. So for a particular application, without knowing the fundamental facts and operational complexities of the drone, if you are equipping your drone with payload with the budget of 20 lakhs or 25 lakhs, it is extremely unfair to proceed with that. Okay. So here you can see the key gases detected by the camera. Here you can see different camera models, how it is used for main industry application. For oil and gas, it is used for regulatory compliance. For utility, it is hydrogen leak detection we can use. And for oil and gas, safety and large emission event detection. So all these different applications, here you can see the wavelength in micrometers, how the different payloads are used for the detection of different gases. Then for noise level detection also we can use the drones. As I told earlier, it is in a particular large scale industry, if you are already having a machine learning model with noise data, if there is a change in decibel, if there is a system malfunctioning, then instantly it will alert the system. Here you can see 5 different spots on a university campus: construction site, pond, hill, sports complex, and gate. So the general noise level of particular region can be recorded already, and that can be processed with your drone. And if there is some abnormalities in the particular region, the abnormal event detection is very much possible with the help of the drone. So though I have presented only very few applications of the drone, the applications day by day it is adding up. And when you add the AI-driven technologies also with your drone, there may be a endless possibility, and there may be endless applications uh, to be revealed by the drone technology in the near future. So thank you all, and I hope you had very much interesting sessions over the past 5 or 6 days. And if you have any questions, please let me know.
Yes, sir. Thank you, sir. If there is any question, participants, you can ask with the different person. Sir, I think there is no question.
Okay.
There is a question in the chat box.
Brief about bio-inspired landing gears for drones. So, though I am doing bio-inspired research for the 7 to 8 years, it is a most interesting question from the audience. So, may I know your faculty or student?
So I think it is from our HOD sir, Gopinath.
Faculty.
Yes, sir. Yes, sir.
Okay, then good. Actually, the bio-inspired landing gears, it will be a new opportunity to design and customize the landing gear. For example, if you consider the landing gear arrangement of different drones, nowadays it is almost fixed. It is you can see a standard type of landing gear. But if you talk about a bio-inspired thing, maybe it is replication of a dog's leg, or it is a replication of a specific bird. It will be a new model, and you have to incorporate with it, incorporate the same thing with your basic drones. And you just once it is tested and customized, you can file a patent, and afterwards you can modify it. So there is a huge research and commercial opportunity exists with with this bio-inspired landing gear. So if you are really working on this bio-inspired designs, please, if you have a excellent carbon fiber manufacturing facility, or if you have a excellent 3D printing facility, you just customize different animal and bird leg configurations and try to incorporate it with the basic model drones, and try to customize a successful design. I have one or two proposals for this particular side, but not yet I have tried. We are in the stage of preparing the models with the Creo, and maybe in the near future, if you want to collaborate, we'll discuss and proceed with that. So hope I answered your question, and all the best.
Yes, sir. Yes. Thank you, sir.
Okay.
Yes, sir. Thank you, sir. Thank you for once again joining and making this session more interesting. Thank you so much.
Thank you. Thank you. Thank you all.
Participants, I want all your kind attention for another 2 minutes. I will just uh, go through the process of attending the assessment. I'll just take 2 minutes. Sadi sir, I'll just take 2 minutes, sir, and then we'll start the session, sir.
Absolutely no problem.
Yes, sir. Thank you, sir. So I'll just share the screen. So participants, I'll just share the screen so that you will be able to know how to attend. So this is the portal. I think each and every one of you will be having a password and username to join the portal. So once you have joined, you are getting into your portal. There is an option called assessment. You have to. I'll go back and I'll. So this is the general area. When you click assessment, there will be an option. You have to find out the application number. This is our application number, or you can find out from the date from and date to. So that this is our FDP. The test link is available here. You have to just click this test link. So once you are getting into the test link, you will have the screen. This screen I have already posted in the WhatsApp group. So there is going to be 25 questions in 30 minutes. You are supposed to answer it within 30 minutes. Once you start, the time will be running on. So you have to attend the 25 questions in 30 minutes. And switch off your mobiles. If you are attending in mobile, there won't be any problem, but there should not be any other additional tabs, or there should not be any switching over of one tab to another tab. So that must be taken care. And the important thing, as I mentioned already, close all irrelevant tabs and windows, and there should not be any copy, paste, and print content during the session. You should not copy anything, or you should not paste anything from the question. So that also It's a guideline provided in the Atal portal. And you can take up the test from 6:30 p.m. onwards. Your response will be saved until you select your response and click the mark for review and save button. So only if you press the save button, your response will be saved. And at least 70% of mark is required for being eligible for the certificate. And also, uh, this is related to assessment, and there is attendance percentage also there. Please ensure that you have a good internet connectivity before the starting the assessment. So once you've done all these things, you have to click I have read and understood and I will adhere to the assessment. Then you can click start. So since the time is not there, it is showing an error. So by 6:30, all of you can start the test. I hope you all got some idea. So if there is any query after this session, you all can put in our chat box, and you can or contact myself and our coordinator, Dr. Gopinath. Thank you. Saji sir.
Yes.
Yes, sir. So we have the next resource person for the last session of the 6 days FTP. Sir has already gave his time, and he has already Sensor Fusion. So he is Satish Kumar, a retired wing commander from Indian Air Force. He's having more than 25 years of aviation experience in diverse areas, including aircraft maintenance, aerodrome infrastructure, and technical training. He's also running his two entrepreneurial startups. One is Will Aviation, the other one is Redome World. So thank you, sir. Thank you for joining, sir. It is over to you, sir. Yes.
Yeah. Good evening, everybody. 6 days of hectic schedule. I can understand. I'm very happy to be the last speaker to close down or to complete your entire successful session of 6 days of rigorous learning experience. I'm sure this experience is going to give you much more in-depth knowledge onto various systems and various technologies, which I'm sure all the speakers would have done it. Without wasting much of time, let me take you through the presentation of mine. I'm going to keep it very simple. Not going to give you too much of stress and concentration. It's going to be a probably like watching a movie. I just want you to have a relaxed time and observe what is going on in today's world. Yeah, I'll start.
The slides are visible, sir, but not. Yes. Yes, sir. Yes, sir. Yes, sir. Fine, sir.
It's okay. Are you able to see the screens?
Yes, sir. Yes, sir. Sir, you're not audible, sir.
We need to
Sir?
understand. Yeah, the days are not very far off that we are going to have anti-drone systems even on our backyards of our houses as well. Future
Sir,
important.
sir, sorry to interrupt, sir. Your screen is not visible, sir. Screen is not visible.
Is it okay now?
No, sir, not yet. I think earlier it was visible, but now it is not visible, sir.
Just a minute.
Yes.
Are you able to see the screen?
No, sir.
No.
No.
Now?
I think now it is getting ready. I am getting a message that you are sharing your screen. I think it is. Yes, sir. Now, yes, sir. Yes, sir.
Okay. Just a minute.
Yes, sir. Fine, sir. Fine, sir.
Yeah. Okay. Are you able to see? Available?
Yes, sir. Yes, sir. It is
Okay.
fine.
So, what are air taxis? Air taxis are nothing but electrical vertical takeoff and landing eVTOL aircraft. To be very specific, they have huge amount of technologies and huge amount of players who have come into this eVTOL arena of technology in the entire world. The current developments, I would say, companies like Uber and even the Amazons have started coming into this particular field of operations. Some of the major companies are Uber Elevate, eHang from China, and Joby Aviation from the US. I will restrict my discussion to these three because there are a huge amount of people who have been working on this technology. Mainly, this is electric. So I'm not gone in for the solar and other stuff as well. And all of these are AI-based autonomous flying systems. And global cities, you must have seen in the news, almost all major cities are testing their air taxi prototypes. Benefits of air taxis is it's very, very obvious. This is going to be time saving, environmental friendly. It's going to be very, very easy than today's road congestions which we see, and accessibility which might be beneficial in terms of connecting remote areas. What are the challenges in air taxi adoption? Probably the first and foremost one is going to be high cost, because the development and setting up all these things are going to involve huge amount of money. Second one, the biggest challenge is going to be in terms of regulations, because we are still ever evolving in terms of airspace regulations and how safely we can operate our air vehicles in the restricted space that we have. And the third thing is going to be public acceptance in terms of building up trust and safety concerns, which will take eventually time for the people to accept it in terms of safety and trustworthiness. The last thing and the major issue is going to be in terms of infrastructure needs, not only in terms of building and landing vertiports. And I think somebody's mic is on.
Yeah, I have muted, sir. I have muted, sir. You can proceed.
Okay. And then critical barriers which are going to be are regulations, the air traffic management, infrastructure, cost, hardware challenges, in fact, and pilot availability in case if we are going to have a piloted vehicle. First one, the case study is about eHang 216, which is a Chinese this thing. Probably they are the fastest to develop the technology, and they have already successfully tested their product in China, and this has been put into practice as well in their country. This is a 2-passenger one, has got a highest speed of 130 kilometers and the range of around 35 kilometers, which they have been involved in the famous Guangzhou province of China. This is a commercially operational air taxi that is there in the world as on date. The second one is the Joby Aviation one. This is based out of US, and it's again electrical VTOL. It's backed by Toyota and NASA. These are the backers for Joby, and you'll be very surprised to know the CEO of Joby is a Coimbatore. In fact, I have met him in Coimbatore. He is very keen on getting this product into India. And this has got a 4-passenger capacity. Emissions, they've got a best environmental rating for the product, and their operational target is just 10 days away. In 2025, they intend to have it fully commercially operational. Now, I touched upon the infrastructure that would be required for a air taxi. That's one thing. The main thing is going to be the vertiports where you can land. you'll be surprised to know, in spite of 75 years of our independence, we have still not been able to come out with regularization, regulations and rules for constructing even a heliport or a vertiport for an air vehicle to land on top of a roof or something. The only vertiport which was formed was in Ames, Delhi. Again, that's still unoperational because of various other regulatory hurdles. If that be the case, you can imagine how difficult it is going to be to come out with policies and regulations and to ensure that our architecture and civil planning happens to such an extent that we are able to come out with multiple infrastructural vertiports which are authorized and certified to be safe. And then how we are going to integrate those vertiports in terms of public transport system as well. See, because we do not want to have, even today, you have villagers fighting in the street for not permitting for expanding an airport. Even in Madurai, be it Coimbatore, the airports are not being expanded just because of huge amount of public pressure in terms of non-cooperation to have their runway expanded. So it's going to be a big challenge in terms of getting these vertiports up and running, not only in terms of high cost, but also in terms of regulatory approvals. Flying over city traffic, how does it going to happen? It's small things which probably the Jobby had worked out of Delhi, how the air taxi can connect somebody from Connaught Place to Gurgaon, which generally takes at least 1.5 to 2 hours of journey, to complete it by around 7 minutes. In spite of having an ever operational IGI international airport en route. So that's one thing which somebody has worked out theoretically, but how well it will happen practically, it needs to be seen. And if you see the plan, it costs close to around 5 million for one particular eVTOL. So that itself makes it very clear that it's going to be an exceptionally costly affair than even today's helicopters, which come in the range of $1 to $2 to $3 million. Safety and regulations, as I said, to give you the major glimpses of what is it going to be, how are we going to avoid a collision avoidance system. Like, you must be aware of the IFFs and the TACAs, the threat collision and avoidance systems which are there existing in the aircraft. How are we going to do that in terms of an eVTOL or multiple kind of activities which are going to take place if you're going to have a commercially operational air and then how are we going to make present day operations of aviation. You must be aware, last month we had one particular air emergency wherein one particular aircraft was circling over Trichy for good about 2 hours, and the entire media was behind what's happening, why the aircraft is being circuited for 2 hours to land back because he had to burn the fuel before he landed. So how are we going to take care of any kind of emergency landing protocols when we have multiple air taxis flying? And then this is going to be again a big challenge for the Civil Aviation Authority, because even now, last month only, the DGCA had decided that they would come out with a separate directorate for helicopters, which that's almost after 70-80 years of helicopter operation. Like, to give you a small glimpse, the states like Tamil Nadu don't even have a department called as aviation. You'll find the transport department, you'll find the industries department, you'll have finance department, you'll have some welfare department, but you do not have even a department to deal with aviation assets. So how are we going to create those stuff in the entire system of ours to take care of this? And then come out with urban air mobility policies which can be ensured that they are trustworthy and safe. The future advancements in air taxis, it's going to be again AI and how we are going to do autonomous flying. The third thing which would be very important is going to be sustainable energy, because as of now everybody is working on mostly working on battery powered ones. There are very few which have come out with solar ones, but they are not effective nor going to be economically viable. So that's another major area. How are you going to look at sustainable energy source for an air taxi is going to be a bigger challenge again. And then how are you going to take on global expansions in terms the pilot project cities like Dubai. They had tied up with EHang and then started it in Dubai, but still they have not been able to come out with a long range eVTOL or a global connectivity kind of an eVTOL.
Hyderabad-based robotics firm have.
Yeah. The third thing is I mentioned AI integration into air taxis. The role of AI can be some of the ideas are into autonomous navigation and the collision avoidance. Then can be something to do with real-time route optimization in terms of traffic monitoring and other stuff. And this is going to really bring down your operational cost and enhance your safety and predictive maintenance activities. Energy solutions, as I said, mostly we are working on electric motors or batteries, and then there are some solar panels. We need to look at how are we going to develop high capacity batteries, and how are we going to integrate the high powered solar systems, and then how are we going to store that energy and then create charging infrastructure also. Like even today we have a multitude of electric cars, but the charging infrastructure is a challenge for the public to go boldly and purchase an electric car. So that's again going to be another challenge where how are we going to make up the charging infrastructure. And then there are certain areas such as hydrogen fuel cells and other stuff which in which a lot of R&D is going on, which might facilitate us in taking on to longer flights. I'll just highlight on some of the things which has happened in India, and all of you must be aware, IIT Chennai is where model has been they are doing the R&D and they are India towards the second news is you must be aware that the biggest airline in our country, Indigo, has already signed up with the Archer for all electric air taxi service. I just want you to highlight and see the numbers. They have already ordered 200 air taxis, which are to be supplied since 2026. So we are hardly a year away from getting to see around 200 eVTOLs flying in our country. You must have seen the trending news in all Twitter and other stuff. Earlier, college student built a drone capable of carrying one single 80 kgs, and we did a small test flight as well. Huge amount of applaud from a lot of people. Civil aviation was commented on that, and in fact, Anand Mahindra also has talked about this person's this thing. So why I wanted to show you this was because the R&D space is not limited to any corporate or big multimillionaire. Even college students have taken up this as a challenge, and they have gone and implemented them as well. Economic impact, yes, as all of you are aware, it's going to have huge economic impact when air taxis are going to be in place. One is in terms of job creation. It's going to be a huge numbers for pilots, engineers, and technicians. Urban mobility transformation, there will be a huge transformation to the way we move and travel around. And then this huge amount of investment opportunities as well as a business perspective. And it's going to be a big boom for the tourism industry, especially because you are going to connect a multitude of locations which are remote, and you are going to have so economic impact on tourism is going to be very, very huge. How big or how feasible it's scalable? If you ask me this question, yes, scaling of air taxi is going to be a huge challenge because of infrastructure limitations, the pilot or the autonomous systems limitations, and then effective strategies for scaling. How are we going to do that scaling as well? Although I see Indigo employing 200 air taxis, but I'm sure it's not going to be in one particular area. It's going to be diverse and divided. So it would be a big challenge for them also to scale up because of having the necessary infrastructure, and then have those modular vertiports wherein you're going to have multitude of eVTOLs landing and takeoff. And then how are we going to do the fleet management as well? That's also going to make a big difference. Key players, as I already said, Joby Aviation, Lilium, Nihang, Archer. These are guys. Volvo Copter is the branch of Airbus actually. Even Airbus is into the game. They are going to come up very fast with their eVTOL. Jaunt is another very, very promising company which has been doing very well towards their R&D on this thing. Funding and investments, billions and billions are being invested today in air mobility startups. In fact, some of the leading countries wants their own kind of air mobility solution, because they do not want to miss the bus, and they want to take the boat at the earliest. So that's the reason why multitude of countries are pouring in billions and billions towards R&D in this area. Collaborations, partnerships have been going on, but mostly restricted to government and that their respective corporates. But otherwise, inter-industry partnerships are, as of now, are not very prominently seen. As I said, regulatory framework, again, the importance of robust regulations is very, very essential. Licensing requirements for the operators and those parameters needs to be worked out, because we do not have time. We are running out of time. The products are going to be available, and we are going to be stuck because of the policy restrictions and the licensing procedures and those stuff. So, and again, still as late as last month is the one wherein we worked out something to do with the military airspace and the commercial airspace. If we are not going to come clear on the airspace zoning and other stuffs with regard to air taxis, that's again going to be a very big challenge. Noise and environmental compliance, this will more importantly affect the OEMs who are going to manufacture. That's going to be a challenge for their R&D. And then our all regulatory aspects, I have generally been following FAA and ESA, and notwithstanding, even today, they are leading the way in terms of air taxis and drones as well. Let's take a break and let's have a small quiz. Which international airport in India has partnered with a private firm to introduce air taxi service from the airport? In the sense, like where you have your taxi service, whether you can book in from the airport itself. This international airport wants to have the air taxi service introduced in their airport. Point A is Delhi, B is Chennai, C is Mumbai, D is others. Please specify. Can we have the answers? Let me have a look. Can we have some answers? I repeat the question. Which international airport in our country has tied up with a private firm to introduce air taxis in our country from their airport? Yeah, any answers? Okay, it's from Dr. Mohan Reddy, Bangalore. Any more guesses? Okay, let's go to the presentation again. Yeah, somebody said Mumbai and others. Mr. Mohan Reddy said it's D, and he's right. Kempegowda Airport had signed up with one of the private firm, named Sarla Aviation to launch electric flying taxis. What I want you to see is the date of the news. It's on 17th of October this month. It's hardly 2 months now. So it's fresh, and we are moving ahead in India. Coming to the next part of my presentation, the anti-drone systems. A small overview. We need to know what are anti-drone systems. These are systems used to detect, track, and neutralize unauthorized drones. Okay, why do we need it? Why do we need it? That's obvious answer: to prevent threats to our security and privacy or the public safety. Where are these as of now applied? Airports, government buildings, and primarily, more importantly, in defense. Now, some of the anti-drone technologies, these are not final list, these are shortlisted. One is detection, like use radar or RF frequency scanners. Neutralization, we use jamming, laser-based systems, and drone interceptors. Most of the airports use these kind of anti-drone systems as on dates. And some of the components that we need to look at is how are we going to detect, how are we going to identify, and how are we going to neutralize. Like if you want to detect, you can use radar, camera, RF, acoustic system, and those sort of stuff. And in terms of identification, we can have it as RFID tags or image recognition kind of stuff. And neutralizing, as of now, most of the techniques which are used are on jamming, hijacking, or capturing and making the drone brought down. The major factors in a design guideline with regard to anti-drone technologies: how are we going to deploy the detector optimally? That is the first and more important, because that's going to be the monitoring agency for how it's going to identify anybody, any rogue drone. And then the threat evaluation model, because you need to know when in a situation where multitude of drones are flying, which is a friend or which is a foe is going to be a question mark, and how are we going to do it? And that threat evaluation model is going to again play a big role on that. And then the risk management system, how are we going to assess the optimal response for that after the threat has been detected. Okay. In future, we are going to look at drone stealths, lowering RCS, and bird shape like frames are going to be bigger things. Even today, we have ornithopters, which do the job of a drone, ideally resembling a bird. And then how are we going to have the encryption methodology between the communication system between your controller and the drone? That's again going to be another factor where futuristic activities have been taking place, and then huge amount of anti-drone solutions are coming into the market day by day. Like, as I said, if I have to take an example of LiDAR data augmentation, initially the raw data is being acquired with utilizing this thing, and then how we take up in terms of how they go, and then target detection and those stuff are again point by point decided. And then this each and every role, this activity which is being increasing, and then the technology is being evolved. Types of drone threats, like as I already said, majorly present day war scenario. Defense is the one which is being concentrating towards anti-drone systems because of unauthorized surveillance as well as weaponized drones, which are become target for the enemies. Second area where we are looking at anti-drones as of now are the airports, and some of the major events which take place, like the CM is participating, PM is participating. The first thing which is being announced is the collector says no drone flying allowed on that particular day in that particular city, of that kind of stuff. But as of now, we have already started coming out with some anti-drone tech for even restricted area, or only deployable only for that particular area and for that particular time frames. So even in urban areas, smuggling and illegal surveillance purposes, these are being used. Future scope, yes, national security, I've already mentioned. It's even be it today's both the wars, Russia, Ukraine, and Israel, Hamas wars, anti-drone systems are deployed in a huge way. Last week also, you must have seen Ukraine employed good about 200 drones to destroy a target in Russia. Yes, and then urban UAM, urban airspace management is again going to be a big area where anti-drone systems are going to play a role, because when we talk of air taxis, a multitude of drone delivery systems kind of stuff coming into play, UAM is going to play a major role in identifying and stopping anti-drone systems. And then how are we going to do the AI-based perception and taking the future skies into safe way operations. AI and machine learning, integrating these into our existing anti-drone systems is going to be a major development in technology. And these are going to be deployed. In fact, our government has already finalized a lot of smart cities wherein they are going to do anti-drone systems as part of the smart city development itself. Social acceptance of air taxis vis-a-vis your anti-drone systems are going, and drone deliveries as well is going to be a big issue because of public concerns raised on these both of these, and then even building trust in terms of safety and other aspects. As I said, some of the technologies which are used in anti-drone systems, one is the radar systems. Both kind of radars are being used, passive, non-passive as well, active radars as well, RF jammers, laser-based systems, and drone interceptors. All these are in key technologies that are growing with a lot of developments in them.
Sir, you are not audible, sir.
Am I now?
Yes, sir. Yes, sir. You are now, sir. Yes, sir.
Yeah. Okay. So anti-drone case study in Dubai airport. So after the incident of their oil tanker being blown by a drone, they immediately involved the major players in the anti-drone system and then secured the Dubai airport with that their present-day anti-drone system, which is employed there. As of now, they use radar and RF jamming systems. They do not have a kill kind of anti-drone system, which is there. Now there's huge amount of betterment in Dubai airport, at least. Second one is the Gatwick airport, because you know the unauthorized drone caused close of this UK Gatwick airport for a long time. Almost 1,000 flights were affected, and then immediately they implemented the anti-drone detection system. It's again a detection and a neutralization system rather than a kill kind of anti-drone system, which has been employed in Gatwick airport. In India, we have been facing Pakistani rogue drones in fact on a day-to-day basis. Even yesterday, you must have read the news that there was close to around 7 drones were brought down in the Rajasthan border, where there was illegal smuggling going on utilizing these drones. So Indian armed forces have been keenly towards implementing anti-drone systems. Army of late has come out with their own anti-drone system as well, and there are some private players who have already come out with anti-drone technologies which are being supplied to our defense forces. The technology used as of now is all purely radar-based detection and RF signal jamming, wherein they try to cut down the communication between the transmitter and the drone. Environmental impacts, yes, positive. There's reduced carbon emissions than your road and rail transportations, and then because of use of renewable energy sources. But challenges, again, as I said, energy intensive battery production is going to be a challenge, and then disposal of your old batteries also is going to rise as a pose a threat in the longer time frame to come. This is Vajra shot, an India-made handheld anti-drone gun with a range of almost 4 kilometers, which is being, as of now, supplied supplied to BSF, the Border Security Force, and Army as well. It'll be a surprise to all of you. This Vajra shot is being manufactured in Tamil Nadu by Chennai-based company, Big Bang Boom Solutions. The second one is Zen Technologies, a Hyderabad-based anti-drone system. This is again for the defense services. The entire anti-drone system consists of RS-based drone detector, video-based drone identification and tracking in terms of whether to identify it as a friend or foe. They just use video, and then radar is employed for tracking it. Data fusion and command center is at the track and in a location, and it needs your human intervention to decide in terms of employing the RF jammer or go ahead with a hard kill. This is being developed by Zen Technologies. Our PSUs are not to be left behind. Bharat Electronics Limited again produces an anti-drone system. It's purely for non-defense applications. As of now, these are being tested in some of the airports in our country, and DRDO has been assisting them in getting this product up and running. Come to the question for today on the anti-drone systems. Which corporate house has introduced a latest counter-drone system in India? A, Reliance, B, Tata, C, Mahindra, D, Atal. Can we have more participation this time, please? I repeat the question. Which corporate house has come out with a modern anti-drone system in India? Reliance, Tata's, Mahindra's, or Atal? Okay, Mr. Kaushal has mentioned it as Reliance. Okay, Mr. Hicet Aero says it's C, the Mahindra. Any more answers? Okay, one for Reliance, one for Mahindra. If the answer is C, you must have seen the news item, which was as late as 6th of December. It's in the Mahindra Group, which is coming to drone tech for civilian defense and other applications. And UP police have given the demo on 6th of December. Future impact of anti-drone systems is going to be, again, as I said, going to be integrated with smart cities, real-time drone monitoring in urban airspaces, and then data sharing with air traffic control nearest airport. And then in the defense infrastructure, again, in the full of border areas in our national security are going to be with anti-drone systems. You must have seen even Bangladesh employing drones for disturbing our peace in the recent times. And in the public sector, we are looking at not only airports, but almost all critical facilities, even in terms of hospitals and big industries and events, going to have these anti-drone systems employed. Applications, as you are aware, in the defense, neutralize the surveillance drones and then protect the critical infrastructure. In technological, as technology is deployed, as of now, the major ones, the latest ones are laser-based systems. Anti-drone market, yes, it's a great market to be in today. It's expected to grow to almost $3 billion by 2028. Within a span of 3 years, it's likely to almost go 4 times. And sectors which are driving the growth are mainly defense, infrastructure, and smart city projects. Increasing reliance on AI is going to be the innovating factor in this technology. Collaboration between air taxis and anti-drone systems. What is the kind of integration needed? If you see, to have safe coexistence of both these, we need to have integration between both of these. The challenges that might be in the picture are managing high density air traffic and preventing interference between operational and unauthorized drones. The solution which is suggested is the unified traffic control system for drones as well as eVTOLs. maybe powered by AI. Again, when I said unified air mobility ecosystem,
Sir, you are not audible, sir.
am I?
Yes, sir. Yes, sir.
Yeah, okay. So I think I'll go back one slide. Components, we need to have all these integrated together, and smart cities role is going to be huge in this kind of integration. Challenges, we have discussed the airspace management challenges when we have air taxis. Now you think of air taxis, delivery drones, and your anti-drone systems in place. How are we going to manipulate and manage the entire airspace? So one is going to be the commercial airspace, which might be above 29,000 feet. And the second one is the UAM corridor, which can be between 100 feet to 6,500 feet. And then low-level airspace can be thought about up to around 400 to 500 feet can be taken for drones. This is a small idea, but in practicality, this might take a lot of difficulties in implementation as well. So because we need to look at avoiding collisions and communication interference between each one of these as well. Environmental impact of anti-drone systems is assessing the carbon footprint is almost known, because some of the anti-drone systems do have ecological aspects of energy as well, because of radar and jamming systems, and long-term environment benefits have to be studied. Real-time drone traffic monitoring, as I said, AI is going to play a very big role in terms of developing centralized control towers for drones as well as for air taxis. We are not left too behind. We are looking at a lot of industry partnerships and collaborations. We have already worked out with some of the industry partnerships in terms of some big names in aerospace companies, including Airbus and Boeing. We are working with some of the urban planners and government bodies in the state level as well as central level. Something which we are working can be mentioned with. We are also talking terms with Uber Elevate team of NASA as well. And we are looking at Indian startups collaboration for anti-drone systems as well. Vision for the future, connected ecosystem for all these air taxis, anti-drone, and your delivery drone kind of stuff for safe and efficient urban air mobility. Final thought is the future of urban airspace is blend of innovation, sustainability, and collaboration. That's where it's going to take shape. I've finished, and I can answer any of your questions that you may have.
Thank you very much, sir. Thank you very much for this very informative session regarding the anti-drones and air taxis. Thank you, sir. Now the participants can ask the questions or any queries if you have. Otherwise, you can put the questions in the chat box also. I'm requesting the participants.
I think there are not much of questions.
So there is one question in the chat box.
Yeah. What role do drones play related to sustainability aspects? Dr. S.S. Mohan Reddy has asked this question. What role do drones play related to sustainability aspects? I haven't got your question properly. If you can slightly explain, Mr. Reddy.
The UNO has some the sustainability development goals, the different goals. So the sir is asking about what is the role of drones with related to sustainable development goals, like smart city or something else. Yes.
Yeah, if you see, Dr. Reddy, there is a huge amount of pressure on every country to reduce the carbon footprint. Nowadays, ecology and the economy are being linked. They are being charged with fines for not maintaining the global environment. This is one area where you have found the ethanol blending coming into picture in terms of ATF, and you must be aware even India is in a large way contributing to the damages, and then come out with very specific schemes for ethanol blending, and then kept some targets for 2030. These are all again in terms of fuel and the carbon footprint. That's where your drones come into play. As of now, although it looks ecologically safe because of operations in terms of batteries and your solar kind of stuff, electric and solar, but the impact is yet to be studied. As I said, you need to see these systems come into play in a larger scale. Then you might be able to have certain data to assess how well they are affecting or we are saving. Otherwise, by now we should have been almost the entire globe should have been electric by now rather than fossil fuels. So unless otherwise we have this solid data, we might be too early to say whether it's better or not. So the database is as of now less. You need to wait and watch how well this develops. Mr. Kumar has asked which software are you using for simulation purpose except MATLAB. What kind of simulation which we are talking about? If we are talking about pilot training, if we are talking about simulation softwares for how you study the product's performance, these two vary in a big way, because and again these simulation softwares are on day-to-day basis developing in a very big way. How you see the performance of each component is also being assessed. So which simulation software which we are looking at matters, and that is also not very big deal. It's again varying with technological development. Modeling and design. Okay, Mr. Kumar has cleared. It's modeling and design again. Mr. Kumar, both modeling and design have been taken over by AI now. Almost, although even in maybe less in India, but most of our modeling and design aspects have been taken over by AI right now. Drone training software, please. Yes, these are various softwares are being used by the RPTOs. I wouldn't say this is better or that is better, but I'll be honest with you, DJI is yet to be broken with others. Which joystick is best? Again, depends upon what kind of use.
So you're not audible, sir.
Am I audible now?
Yes, sir, you're audible now, sir.
Yeah. Which joystick is the best? As I said, a huge amount of joysticks in the market. There's a you must be surprised. There's a joystick manufacturer in Coimbatore alone, and he supplies to some of the leading flight training organizations in the world, not in India, in the world. So, and the joystick has got some of the, maybe it doesn't have the elegance and look of a modern one, but the practicality wise, it gives almost ultra modern facilities for your operations. There are, I know of few who use it as a for their pilot training in their homes with their PCs as well.
Yes, sir. Thank you, sir. Any more questions from the participants' side?
Thank you, Mr. Shivakumar. Mr. Palani K has got a question. What are the consequences on the temperature when we use more drones that run on batteries? It may increase the global warming. How will it be resolved? Yes, as I said, Mr. Palani, these are areas which are unknown, and nor we do have any statistical data to back up to say yes or no. So the same answer which I gave for Mr. Reddy holds good, because we do not have enough data to sustain our claim that these are going to be ecologically safe or ecologically bad. So these are yet to be seen. Unless otherwise we see the things evolve over a period of time, we might be too early to say they are good for environment or bad for environment or global warming for that matter.
Yes, sir. Thank you, sir. Any more questions from the participants, sir? If there is no more questions.
Thank you, Hicet team, and
Yes.
almost all the faculty who have attended. I see almost close to around 90 plus attended today's session. Thank you one and all. Hopefully, you had a good time in your FDP session. All the best for your assessment as well.
Yes,
thank you.
sir.
Keep in touch.
Yes, Adi sir. Thank you so much, sir. Thank you so much for your time and valuable inputs for this FDP. You have handled the 2 sessions. Thank you so much, sir. Thank you so much.
Thank you.
Yes, sir.
Good day.
Yes, sir. The dear participants, hope you have enjoyed all the sessions of this faculty development program sponsored by AICTE on the title Advanced Strategies for Optimizing Drones, Networks and Operational Efficiency is from 16th December to 21st December. We would like to hear some feedback from the participants.
So, good evening, sir.
Yes, sir. Good evening, sir. Yes, sir. Very good evening, sir.
This is Dr. Vijayaravan from Sankara University, Kanchipuram.
Yes, sir. Yes, sir.
This entire sessions was very nice, sir. Actually, last 1 month itself only I am learning drone technology. Actually, our university is having plan for set up the drone lab. That's why I done that. And this entire workshop sessions are very useful for me, and they have given a real experience like architecture of drone and drone components, and then AI, how to use AI, and then modern technology and applications of various fields, particularly in agriculture, like that. Various aspects. This workshop was very useful, sir. Thank you very much for Hindustan team, and particularly Saravan sir. I thank very much, sir. For your,
Yes, sir. Yes, sir. Thank you so much, sir. Thank you, sir. Thank you, sir.
Sir, good evening, sir.
Sir, anyone else? Yes, sir. Yes, sir.
Sir, I am Ravi Kumar from VNR Vijnan Jyoti Engineering College, Hyderabad, sir.
Yes, sir. Yes, sir. Please, sir.
Sir, all the sessions are very informative, and all the resource persons are excellent, sir. They have explained in a very simplistic manner all the concepts. They have explained in a nice way, and most of the resource persons, I find them working in industry, and they have given nice real-time exposure, whether you say field-wise as well as design and implementation aspects, sir. And even some of the research persons, they have given the future directions also. So that is also like I enjoyed a lot. And lastly, I'm thankful to all the organizers for allowing me to ask questions regularly. Like even though I am interrupting, you have patiently accepting, and you're coordinating in getting the responses. Thanks a lot, sir.
Yes, sir. Thanks, sir. Thank you, sir.
Thank you.
Yes, sir. Thank you. Thank you. Any other feedback, sir, from the participant side? Okay, if there is no more feedback. Yes, sir. This is the right time to give the vote of thanks to all the participants from the various institutions and various industries across the country. On behalf of Hindustan College of Engineering Technology, I would like to give my the sincere thanks to all the participants, because in the AICT portal, nearly 140 participants they have registered for this online FDP. On an average, regularly 100+ participants are attending these sessions. At this juncture, I'd like to give my sincere thanks to the AICTE for sponsoring this online FDP and the co-coordinator, Professor Saravana Kumar, who's taking care of all the activities from the first day onwards to bring the people to the online forum, to purchase the online platform, to organize this faculty development program, and organizing the speakers. So all those things will be taken by care by the Professor V. Saravana Kumar. At this juncture, I would like to convey my sincere and special thanks to Mr. Saravana Kumar and all the participants also. So thank you so much. As for the schedule, your feedback link will be enabled in your Atal portal. Similarly, you can take up the test. The test starts from the 6:30 onwards. If you have any queries, if you have any doubts regarding this, you can contact us through WhatsApp. Otherwise, you can give the call to me, or otherwise you can call to Professor V. Saravana Kumar. In future, we will join all together in another Atal FTP. Thank you so much. Thank you so much.
Sir, one request, sir.
Yes, sir. Please, sir.
Sir, is it possible to visit your labs or infrastructure, whatever you are having on drones?
Yes, sir. By all means. Yes, sir. Yes, sir. You can give the request officially. Then surely you can come and have the visit, sir. Yes, sir.
Thank you, sir.
Yes, sir. Yes, sir.
Thank you, sir.